Yeah, but
Yeah,
why
I
wouldn't?
upgraded all my stuff right when Trump started talking about tariffs.
Another news though. You guys ready for the debate tonight?
What debate?
Alan is debating Astronomy Live on Red Rhetoric's channel. What's up, Theo? Yeah.
Yeah, Rick,
I wonder.
I had to redo my whole system. I had to get a new motherboard, new processor, and new fucking RAM just because my motherboard just fucked up.
When does that debate start?
9 p.m. Eastern.
Thank you.
Here, I just found the.
Oh.
Here, I'll post it. I just went to Red Rhetoric's channel, and looks that's it, right? Yeah, it looks like that's it. Upcoming.
Yeah, that looks like it.
Yeah. Cool.
There you go, Osco. He posted it, but I'm so curious how Astronomy Live is going to actually reconcile it. Like, how is he going to address it? I don't know. I wonder if he's just going to do what everyone else does and just ignore the fact that we're using two relative horizontals and they show flat. They show flat baseline. I wonder how they're gonna.
I'll go with Jesse's argument. Well, if you take away the atmosphere, of course it looks flat. But if you put the atmosphere, it always matches up to a globe.
Insane, dude.
I don't think that's quite his argument.
No one takes away that. That's what he says,
it's
bro.
Close, but you're
no one takes away the Atmos, bro. When he says that we take away the Atmos,
that part he was right on.
Yeah, but when no one's taking away the Atmos, that's retarded, dude. That's actually just referencing the true position of a star based off the 15.04 degrees rate of rotation, essentially.
Well, I don't think Jesse's suggesting that you guys are removing the atmosphere.
He is.
Why is he saying it?
I think he's saying you in Stellarium you uncheck the box.
Yeah, but what does that actually mean, though, right? Yeah, what is
he's turning off refraction.
Stellarium's gonna run the calculation, and it's not gonna apply any refraction correction.
Celestial refraction correction. Yeah, exactly. So why are they presenting it as though? Yeah. So globe equals refraction. Yeah, exactly. So why are they presenting it as if we don't believe in the air?
Well, hold on. That's the part you were wrong about. Elbow.
Yeah, but they're being sneaky on how they present it, though, dude.
I don't think he's being sneaky. He's been pretty straightforward.
Flat earthers think that there's no atmosphere. Yeah, that's being sneaky, bro. No one says that, but he keeps saying it, repeating it over and over again. It's ridiculous.
Well,
39 weeks of this, Pfinky. 39 weeks, bro. They can't get our argument correct.
Turning off the atmosphere. Do you not turn off the atmosphere to eliminate refraction?
Yeah, but what does turning off atmosphere refraction in Stellarium mean? What is that actually doing?
It means it does not apply.
It changes the position of the star.
Yeah, why? What is it referencing then?
So it'll fit flat Earth.
No, it's getting the true position. It's getting the true position.
Thank you, Gio. It's the true position of the star where it's supposed
that's
to be.
Something Alan made up. That's something Alan made up.
Is it where you see it?
No, that's not something Alan made up, retard.
It is.
I guess Alan wrote that piece of code.
Yeah. He wrote all of this.
He did wrote the piece of code?
No, I mean Stellarium's just
actually,
a model. But like your guys' claim
is
that there's a straight line between them. That's a claim that Alan made that I don't.
Okay, how do you think you're able to use celestial navigation with a nautical almanac unless you have fixed position of stars at certain zeniths at certain times across the world?
For starters, don't look at the horizon. Don't look near the horizon.
No shit. How do you think they establish it? They have a zenith. They have a 90 degree of a star at a certain time, at a certain day, at a certain place. That's how they establish the nautical almanac. That's what it's referencing when you turn off atmospheric refraction, dude.
No, that's a geocentric angle. But when you're talking about doing an observation doing an observation from the ground, that's different. That's horizon coordinates.
Yeah, the point to point. You're saying the shortest distance, right? That's straight line, and in between those points, right? Even the point itself, you could draw a straight line through the point, right?
I don't know what you're talking about.
I know you don't.
Yeah, the
I
only
don't
way
feel
they
like that
can
was
make the
related
Earth
to the
fit into a
conversation.
globe is using refraction. That's it.
Like if I have a
Well,
point, you
it's
don't understand I could draw a straight line through the point.
yeah, I'm with you on that. I have a point. I
Okay,
draw a
now
straight line through it.
if I'm going to connect the 2 points, are they going to line up with that line or not?
Where are the other 2
What happened to
points?
the self-theodolite? What happened to that?
Nothing happened to it, left lane.
You're
Stick
done.
around for the debate. Yeah, you guys don't
I don't think we satisfied that previous topic about turning off refraction and
We have a
why.
rebuttal.
Yeah, but left
No,
lane, it's
Wait,
just
what-
I
it's
took a
just
different.
it's turned off to reference the true position to actually analyze the timing. You get the actual like architecture of the timing. But
That's
the
not
thing
where we see it, though.
that is where it's seen.
What? That is
Well-
exactly where we see it, dude. That's what the point of using a mountain.
That's where it
This is
occludes.
what's. So this was my approach with Alan, which he completely ignored, and I haven't tuned in since then. But like use an eclipse. An eclipse is the same thing. It's the exact same principle. You have something.
They do use that.
I know. Well, they don't anymore. Or if they did, they haven't replied to my rebuttal of it. But
No, I'm
if
saying
you-
people using eclipse date, like that's using an occlusion. That's what exactly
Also,
what you would
that's
do.
not
You would
really
use the true
repeatable,
position.
right? You
okay,
can't like.
so you should
That's
try
not
it.
exactly
Basically, you
repeatable
should
as
try it. You
partial
should take
Galois, right?
You should
No,
take
but Pfinky,
you should
your
take the
point,
eclipse
I remember.
data and run it through Cell Theo. I'll
I
send you my
remember your
write up
point.
of it, but I did it and it doesn't work at all.
Listen, I remember your point. Your point was if we have the angle from the moon to the star and then to the ground, right?
No, the sun eclipse. Sun. I was talking about eclipse. Sun to moon. to
Sun,
ground.
moon to ground. Okay. And you're saying to take the position from the moon.
Yes, that's what Cell Theo is. You find
Yeah,
the
yeah,
angle.
okay. Can we get to the moon?
No, but stellarium. You guys are using
Okay.
stellarium, and you're
That's
saying
why you
stellarium's
didn't want to
internally.
address it.
Why? Why would it matter if we can get to the moon?
Because you can't actually get to the fucking moon, dude, and actually verify it yourself. What are you talking
What
about,
would
dude?
Using the same
Okay, no,
principle,
hold on,
though.
hold on,
Why
left lane,
couldn't you
hold on,
use the same
hold on a sec.
principle?
Let's say I went to the mountain for Cell Theo. What would I verify?
I don't know that you're a good hiker.
No, I mean,
What are you
like, what would
talking
you do
about?
on the moon? Like, so we could climb the mountain by Dr. Heffron's house, right? What
Okay.
would we verify if we went up there?
I don't know. Why are you asking me this? Why would
I'm
you need to
asking you
climb up there?
because there's nothing that you could verify according to the Cell Theo method by being at the location.
What are you talking? You're just saying a vague statement. What do you mean?
No.
There's nothing you can verify.
You just said the reason he ignored it is because we can't climb to the moon. And I'm asking you, okay, if we could go to the moon, what would you verify? What's the important data
The
that you would need to be
angle.
there to verify?
The angle, dude. If I'm on
you're
the
not-
surface of the moon, supposedly, and I'm looking at the sun and the earth, all right, and then I see and I measure that angle. Okay, if I could actually get to the surface of the moon, then your theory would, then yes, it should be a triangle. It should be you should be able to do that. The problem is, bro, we're here on Earth. We can only do what we can do here on Earth.
No,
Like,
I know,
I don't.
but like,
there's no
you're not
point to what
using
you're
the
saying,
angle.
though.
You're not
Can you
using.
address the actual data in the Cell Theo presentation, though? Like, can you guys actually talk about
I
the
did
fact
address
that?
it with the
I
eclipse.
would like
addressed
for him
it
to
in-
finish. I would
the
like for him to
point.
finish what he's saying, maybe.
But do you understand like the significance of it? Where if we are talking about a timing, right? There's only one occlusion time. That's it. Period. One time, right? And every single measurement, it has the globe basically being off by the amount of drop that is supposed in the first place.
Except
Do you
not for
understand how
eclipses.
crazy that is?
Except not for eclipses.
But not for you're just going to ignore what I just said.
No, I'm just going to say why, if it works for mountains, it should work for eclipses.
But do you understand the significance of that? Why are you ignoring what I'm saying?
I'm not. I'm just saying if the method works, it should work everywhere. And all the observations to date are right at the horizon where there's the most confounding effects. Eclipses happen up in the sky where you don't have the extreme celestial and atmospheric refraction. So look at those and see how well it works.
How come no glober actually wants to fucking address the data that we actually accumulated over 39 weeks? Well, what about eclipses?
You guys posted eclipses. That's part of the Cell Theo. I listened to 3 presentations and I know about eclipses, so I took that on. I did a whole write-up of it and they just ignored it. As you are ignoring it.
I'm not ignoring it. I can't get to the surface of the moon to verify it.
You're not getting to the surface of a mountain to verify it. You're just using
that's a non-point. Can we address like what's actually been presented? Dude, the fact that if I take the arc length, which is from the observer to the mountain peak, okay? If I take that arc length, okay, and now there's supposed to be a drop over distance between me and the mountain peak, all right? Let's say it's 27 arc minutes. The drop over distance is about 13. Okay? You with me so far?
Address the point.
Are you with me so far, Pfinky?
Maybe change the topic.
Oh wow. Okay, so he doesn't want to address it.
Talk about it. No, I said.
Yeah, no one. Are you with me or what? Okay. Well, are you following what I'm saying right now?
Yep, I said I'm with you.
Okay, you're following me. Okay. Now, this drop over distance is presupposed. We don't know that it's there or not, where it's just presupposed for the globe. Now I take that observer, I put him on the top of the mountain peak at the exact same time and take the true position of the star. All right. We should be off.
Put him there.
We should be off by the amount of drop that we did not account for. But it's the opposite, dude. Do you understand the significance of that?
Yeah, yes. You're off. Okay, hold on. You're off by amount of drop if you pretend that refraction doesn't occur. Can we agree to that?
What do you mean pretend that refraction doesn't occur? What are you talking about?
Turn off refraction.
Okay, if we grant you refraction, right, then what you are saying is that the only time there's drop over distance is if it's an optical effect.
No, that's not what I don't think that's what we're saying.
That's what you're saying.
Explain that. No.
You just said if you don't take into account atmospheric refraction. Okay, we add it back in to what? To get the flat baseline, to match up the observation. You understand how significant that is? That means there is no actual drop over distance.
What did you start with? Globe dimensions?
Let's say I accept all that. Let's say I accept all that, and then I say, okay,
and you'd be a flat earther like Dr. Mike.
Well, no, because we say the ambiguous part is the refraction. So let's say now let's find an observation that's up in the sky where the amount of refraction is going to be small. Like you can go look at the stellarium calculation for refraction, and you can see I have a spreadsheet where it shows the amount of correction that it puts basically by degree by elevation angle.
It's just a calculation depending on the angle, right? Yeah.
When you get up into the 30, I mean, it has to be. It's just an app, right? So
why does it have to be though?
When you, like, what else would it be? When you get up in the
not a globe.
Sky, right. So if you get up in the sky, the amount of correction is like very, very small. Well, I don't say very, very small, but it's small, right? If you get up 30, 40 degrees up, that's why you don't do cell nav on the horizon. So let's find observations that are up in the sky where we don't have that. We don't have to fight over whether or not we're going to turn off refraction. I'll let you turn, turn off refraction for eclipses.
Let's take an angle that's so close to the flat baseline that it's hard to differentiate between globe and flat. Yeah, thanks.
Wait,
there's a reason why we want to use. There's a reason why we want to use angles towards the horizon, right? Because then it accentuates the difference between a flat baseline and a globe. The drop over distance. Every single time, the drop over distance is what you guys are off by.
Well, if that's the case, then if we look at eclipses, the numbers should
are you going to eclipses?
Together. It should be indistinguishable. It's not.
It's a different.
The flat Earth gets absolutely. It's not even close.
Yeah, but dude, one method you're taking like a little pinpoint. That's like so much different than an eclipse, and trying to measure all parts of the eclipse with occlusion. Like what? How is this even relevant?
No, because we know the exact moment of occlusion at any given point in time. The eclipse
so you agree with the true position of stars, the true position of the sun, and the true position of the moon, right? You agree that that's how they predict when you have totality, right, of an eclipse?
Running a rail off.
I'm not running the rail off. I'm addressing his point directly, left lane. Thank you.
By the way, I did this in my write-up. I posted it. I went and I used I think the JC 2000 Or no, it's equator of date. That's the one that Alan
right. It depends. The epoch. Yeah. Whatever epoch you use. Right.
So
the
I
point
used the
is,
equator of
you
date,
accept.
and I ran celestial theodolite. Why do you think it came back so bad?
What do you mean you ran? What was it? What does that mean?
I did the cell Theo method.
Send me your write up.
I posted up above here. I'll post it again.
Yeah, send it to me in a DM so I can actually read it. I'll address it fair and square. But real quick, I just want you to agree with me that they do use the true position, not the apparent position, the true position of where the sun is, where the moon is, etc., to figure out the totality of an eclipse, correct? They don't actually use the apparent position, right? Refraction, celestial refraction. They use the true position. You agree?
Yes, I think so. I don't know for sure, but I believe so.
Well, they do. They do. For sure, they use the true position. All right. Now, if we're using the true position of a said star, okay, we're using the true position in order to compare our prediction and globe prediction to, and every single time the globe prediction is off by the amount of drop that is required at that distance. Do you understand why Dr. Mike? Yeah. Do you understand why Dr. Mike's a flat earther, bro? Like, I'm talking about multiple observations, multiple peaks, multiple locations. It's not just an anomaly on it just Pike in his house. Like, there's multiple observations and multiple peaks, and this has been done with.
They don't. I mean, they don't all though. Jesse's posted ones where the globe is closer, and again,
it's not closer.
All on the horizon.
It is too.
It's not closer. You're talking about Blinn Mountain.
Yeah, Blinn Mountain.
Yeah, Blinn Mountain. If you look at the actual arc length, okay, the globe is all the exact same amount, the same amount of drop that's supposed to be there. If you actually look at the data,
what about turning this guy back on?
I think when you say look at the data, you mean if you run a calculation in a
no, like look at the actual data, the data that Jesse provided. You can actually look at it. All right. Now, what he says is the amount of refraction that is incorporated, it lifts it back up to what? To a flat baseline. There you go. So what? So that means that you're okay with the drop over distance only being optical.
No,
GG.
No, it's. I mean, you can try to put words in my mouth and say GG, but that doesn't.
You're done.
That doesn't mean anything. And you've still ignored, like Alan and Shane. I promise you're not going to address the.
Do you have a rebuttal?
What you're going to say?
Yeah, do you have a rebuttal for that though? I know you comment on the GG thing, but do you have an actual rebuttal for what he just said?
Yeah, it doesn't.
Nope.
Like the globe already predicts perfectly where we see the star, and the part that I'm not. It does. Like you go out, any of us can go out. You can look on the horizon, and you're going to see the star where the globe says it's going to show up. So I think it's set up to where there are certain you can find certain locations where.
I'll tell you what, Pfinky. I'll extend it to olive branch.
I think you can find certain locations where the way that the thing is set up, the turning off atmospheric refraction will make a closer result. It's why, but I like the eclipses because it's unambiguous. It's not even in the same ballpark, and it should be if the method's correct.
No, the
Alan
method,
and Shane ducked it
the
and
method's
refused
like
to address
you're
it.
doing something different. How are you getting this to work with eclipses? That's what I don't understand. How are you doing your occlusion timings with something that's like so close compared to a star? Like you're looking at like this little speck. And you're saying,
How do
okay,
you know
when this
one's
little
closer?
speck
How
hits
far
this
away is a
point,
star
it's
versus
tiny,
a moon?
tiny peak, then boom, I'm a snapshot. What are you doing with this method on an eclipse?
You stand in one spot, and as soon as there's a complete total eclipse, then you know that the moon has fully occluded the sun. That's how you do it. And you write down the time. And the good news is we have 1,000 data points of every eclipse where we can look at the exact location, and we know the GP of the sun, we know the GP of the moon, and we can go.
Do you do the refracted distance? Do you do the refracted positions or the actual positions?
Either of them.
No,
if you pick all the ones up high in the
you're
sky,
saying that A and not A
they'll
can be the same at the same time in the same sense?
Bro, you're using actual
Put out the
positions.
energy.
They use actual positions. Let me help you out, Pfinky.
I
don't want
think
you
they
to.
use. It
So
depends on the
it's
one.
the case that they
I
use
think they use
one
good
over the
refraction.
other. You can't use both, right? It isn't the case that you could just say A and not A, give the same result in the same sense at the same time, right?
Absolutely. Yep. Exactly. No, they don't use refracted positions, bro. They have to use the true position in order to predict totality.
Do you
I
have
think
a
they-
rebuttal?
I don't
The
know if
point
they use
is,
refractive. I'll look into that.
they don't.
I have. So they
I'll
have
save
a
you time.
they have a spreadsheet. I actually made an app for eclipses. I can go look at if an underlying library includes refraction. But I got basically the same numbers as
Bro.
far because there was a spreadsheet that they published with the eclipse stuff that
They use
showed basically the angle, like the observed angle, that they had their calculated angle or whatever.
The observed
I don't
angle
know.
and then the true position, right? The true angle, right? So then they basically do a subtraction. So based off the occlusion, right? They basically subtract the amount of refraction that had to be there because it's not matching with their true position. That's the difference. They have to reference the true position in order to get totality. If they're referencing the true position and we're referencing the true position, okay, what is the difference?
This is my point. At 30 degrees up in the sky, which we have plenty of data points, I don't think it matters.
30 degrees off of what? 30 degrees off of what? What are you talking about? Because I'm going to need an entire map. I'm going to need an entire map of the universe and the radius of the universe before I even consider your position.
30 degrees.
What happens if I get to the edge of the universe? Do I fall off?
That's a good question. I think the universe has a big spandex container, so you probably wouldn't fall.
So would
off.
you say that it's infinite
spandex?
radius? Would you say that the radius of the universe is a finite number or infinite?
Radius. I think it's probably finite. I don't know.
Well, they treat the celestial sphere with an infinite radius.
So you're saying the universe is finite?
Yeah, I think it's finite.
I mean, it's all a conceptual model, bro. I mean, the point is we're testing the internal consistency of the model and showing that it's consistently relying on flat baseline angles to stars in order to basically complete the model. You can't even incorporate how much
Go read my doc and then come back.
Listen. You can't even incorporate the amount of refraction until you get the angle. Do you understand how crazy that is?
Why is that?
It's not crazy at all. Why is it crazy?
Because what is an angle? Two straight lines, dog.
And
oh boy, we're doing the Oakley, like you have to have a flat.
Yeah, Nathan Oakley, you got to use a flat baseline. Well, fucking of course you do. It's the horizontal at your feet.
All right, now I take two. Now, if I have two relative horizontals that are 56 kilometers apart, and then they both reference each other in a succinct way to where it matches the exact timing of when a star is in a certain place in the sky, according to your model, then what? What are we doing?
No, that would be a straw man.
I think there's points. I think there's points.
A straw
in
man?
time.
What do you mean it's a straw man?
No, hold on. I'm going to grant you. I think there are points and there are locations and points and angles where it would more closely match flat Earth than it would globe with refraction turned off.
How about 56 observations?
I mean, it's possible that just by looking low on the horizon, that most observations doing this method with the mountain would report closer to flat. It's definitely not like exactly flat. Some of them are some of them are like way far off, but
come on, Pfinky, do you understand what you're saying right now, dude? Like,
yeah, I do. It's not a very reliable method, and eclipses.
Oh,
when you see the eclipse stuff, it's gonna be not good, and you're gonna ignore it.
Dude,
I think we're just looping. I think we're looping. So go read it. I've posted
How
it.
are you measuring? How are you measuring the occlusion during the eclipse?
They kind of use like
it uses
the time. The whole point of celestial theodolite is the timing. So the moment that that it turns black on your location, you know that you are in line with the shadow. I don't see why that's that hard.
Yeah, that's very difficult. That'd be like fractions of a second, because you're saying when the moon fully blocks out the sun, well, you got to measure that very precisely. And I'm saying, how are you doing that just with your eyeballs?
When the shadow
You're
hits
saying
you,
a
it's
shadow?
just like
That's your
it's the
answer?
same as
A
like watching
shadow?
it's the same as watching a star go behind a mountain. It's like you see
No,
it
it's
and then you
not.
don't.
You have a fucking speckle that you're chasing. This, you have a huge circle. It's completely different. And you're saying the very second it's fully encompassed. You know, it fully blocks out the sun.
Oh,
That
it's
millisecond, I'm
it's
taking a
very
snapshot.
significant.
So now
It's
you're
very
comparing a huge circle,
no,
right?
it's not the huge
Fully
circle.
encompassing, blocking the light to a little speckle.
It's the
A little
moment.
speck.
It's the moment that it occludes, and it's very obvious when that happens.
No, it's not obvious.
Oh, if you ever stood and watched an eclipse,
Yeah, you can measure it to
there's
fractions
no
of a
measuring.
second.
Yeah,
you
it
can
just
measure
it
that
just
shit
blinks.
to fractions of
It
a second.
it blinks out, and that's when you
It doesn't
record your
blink
time.
out.
Oh, yes, it does.
Oh no, it doesn't. You can measure
And there's
it. You can
Oh,
measure
I've
there's a
seen
center
it.
path. There's a center path of the eclipse also. So you could take basically you just take the start and end, and you can take the middle point of it, and then get yourself in the middle of the shadow.
Tracking
And
the
you're
middle
at the
point
perfect,
of the moon now.
perfect
Come the
center
fuck on.
spot.
So
And the thing
nothing
too
to
is
do
like
with this method.
it's so short. It's so short. It doesn't matter. You can do it from the beginning. You could do it from the end. You're not going to find one that lines up with flat Earth.
So
not
absolutely
even
nothing
remotely.
to do with the method, and not applicable in any way, shape, or form. Okay,
It is. It's an occlusion.
I
An
just
occlusion
it's
makes
an
a straight
occlusion
line.
that you can't. Yeah, you're comparing an occlusion of a pinpoint to a huge fucking disc in the sky.
An occlusion is an occlusion, dude. I don't know what to say.
Yeah, but you can't measure that much area. You're not going to be able to.
You're not measuring that bunch of area. You measure it
Yes,
from
you
at the
do.
point
You're
that
saying at
it
the
blinks
very
out.
moment of occlusion.
You don't even know what you're talking about, dude.
The funniest part is that
You're not
Shane and
following
Alan
Left
brought
Lane.
this up.
That's
I'm not the one that
apparent.
brought it up. Shane and Alan brought it up as because it is an occlusion, and they tried to use it. They tried to use it in a different way. They didn't actually do the method on it. But your beef, I think, is with them, not with me.
No, it's with you trying to force it onto an eclipse and say it's the same thing. You're taking a little pinpoint and you're saying this only like source of light. Second, that's blocked by the mountain. Boom.
You keep repeating
now,
that, man.
You're looking. Just shut the fuck up, please. Right now, you're looking at a huge circle encompassing.
It's irrelevant.
Circle, and you're saying, right? You're saying the moment that entire circle encompasses the other entire circle. At that very specific moment, I'm taking a snapshot. Saying that's bullshit.
Well, what I would say is the moment that
I
go in complete shadow, that's how I know that it's encompassed it, because the shadow's been cast on me.
So you're looking
Angling
at the shadow
Alchemy
on the
just
ground?
posted the presentation that L'Amazing, who is Brian, who did. It's not really like my understanding. This is not like necessarily part of the entire Celtheo method, but it is like connected with the presentations because Brian did that presentation on the eclipses and he did the calculation showing how it matches planar. However, I mean, to me, my understanding of the Celtheo is the mountain with the star on the Earth. I think this was kind of like when Brian did that presentation, it was kind of like an add-on thing or like a additional calculation that he did. And the presentation that Angling Alchemy just posted goes through all of it. And they did one or two of them on here as well, where they went through them. I think that one he posted might be from a different recording, but it's the same information. So, I mean, Rigger, like if you're kind of arguing that, you'd have to like, I don't know, argue, I guess, Brian on that as well, the point you're saying. Because
I'm saying, how can you measure the total eclipse? Like you're measuring such a huge.
No, there's still a timing. There's a timing. There's a timing of totality.
Yeah, we've explained it. It's when it blinks out, dude. It's when it blinks out. That's when you measure it.
I just don't think that would work.
I think in the case of the eclipse, Brian I think he uses the very center point of the sun. I'm not sure he explains it in the video exactly how he does it.
Yeah, that's what you have to do.
There's a center path of the shadow.
Center point.
There's a center point of the
you're
shadow.
Using the edge. You're saying, oh, when the edge hits here, I'm going to just take this timing. Dude, that would be so inaccurate.
No, I think you're right. I think you take the start and end of the total eclipse. The timing is halfway in between them. And for the best results, you want to be right in the middle of the shadow. But honestly, it doesn't really matter.
Right. So how can you use that same method?
Because you have a timing. The whole point is there's an occlusion. You have a timing. That timing tells you the moment those three are lined up. You get the GP of the sun. You get the GP of the moon. You draw a line through it, and that's your angle. And you can see if stellarium matches that angle with refraction turned off. It does, and it's like 50 degrees off.
Yeah, no.
Kind of like it's like using the moon as the mountaintop and then the sun as the star.
For the mountain. Yeah, but exactly. The moon's so damn close, right?
Well, how do you know how close it is?
It's further away than any mountaintop ever is. Even you admit that.
Maybe not.
Well, wait a minute. Do you think it's closer than a mountaintop?
You're comparing distance to like infinite distance. Like that's
not infinite.
That's like the whole method is because the star is so fucking far away. That's why it works.
No, Shane and Alan don't make claims about how far away the stars are. They don't make claims about how far away the moon is. That the whole point of the method is to simplify it down to just when it eclipses, then we know there's a straight line. So we take the GP of both and we see if the angle matches flat or globe. It's very simple.
Yeah, I do think their method's very simple. And I think if you try to use their method on an eclipse, it would not be simple.
It's the same thing.
Think you could
well, think through it. How would it be different for an eclipse?
Because you're not like, you wouldn't be measuring the time it occludes, right? Like the point it disappears. That's not what you'd be doing. You'd be timing it.
But you don't think?
Well, it's a conjunction. It's technically called a conjunction when the sun and the moon are in a conjunction during an eclipse, and you also have a conjunction of the mountain peak and the star. So they're both technically conjunctions.
Yeah, but then you have what? All this shit with like refraction and everything else, like the sun bending around. You know what I mean? It's like, dude, the amount of refraction just on that is insane.
Well, I'm just going with Alan and Shane. Alan and Shane's hypothesis is
like
that
bend around part of the moon too.
Like I'm just going with their hypothesis is that the you don't have to worry about refraction because this is a true position. The shadow itself tells you that they're in perfect alignment. So we don't have to consider refraction.
Dude, how are you looking at the shadow? The whole of the shadow. What are you on about? You keep mentioning the shadow. What, you're looking at the ground to get your timing?
I don't know, man. Maybe you just don't understand what's going on. I don't know.
Yeah, obviously you don't.
You just want to argue it.
Well, Pfinky, have you had a talk with Brian though? Because when Brian did those presentations, I mean, he showed how it all matches planar. So do you have like either a rebuttal or to show how you think it shows a globe? And have you talked with him?
Yeah, I posted twice a rebuttal to his. I don't know when he did his presentation. I read through all the written documents. He had 2 data spreadsheets, and I wrote some code, did a write up, and basically Shane and Alan just ignored it. So maybe he would want to discuss it. I don't know. But I posted it in chat. I'll post it again and tag you.
Okay, well, I'm just saying he was the one that I think did the eclipse presentation. Brian was. So, I mean, if you talked with him, or if there was if you guys did a short event or something where you could go through it and show where the discrepancies are and like why you're saying you came up with a different result than he did, and what the differences were.
Yeah, so this is from 4 months ago. I'm almost certain that my write-up that I just posted addresses everything that he said in this video, because they took the video and then they did Alan added some stuff onto his Obsidian database. There's 3 or 4 pages around the eclipse stuff. But if Brian wanted to read over my thing and talk about it, I would be more than happy to.
Has he even seen it? Or you don't know if he has?
I joined up with Theo and brought it up, shared it. We talked through all the points. Alan said interesting, and then they just kind of ignored it. I don't know if he was there. I don't know if they shared with him, but.
All right. Well, I'm just saying if he's the one that Brian is the one that kind of did, the main presentation on it. So I would just think like he would be the one to rebut if you're going to rebut it.
Yeah, that's probably fair. When I was first introduced to to it, it was being presented by Shane and Alan. I think he's kind of like been, they'll present it and then he's kind of in the background. I know he's answered a few questions from people, but I can't go on their server because I'm blocked. So I just talk to whoever's here. So if he wanted to talk about it, I mean, Shane definitely doesn't know anything about it. He doesn't, but Alan seems to like know a little bit, enough to like hold a conversation, but.
Okay, and you're saying you think it gives a globe result?
Yeah. Yeah, the flat Earth prediction, it's off by, like, if you just do the straight cell Theo, it's like off by, 45 degrees. The part of the thing is, if you just think about an eclipse, the sun is almost always directly over the moon. So the angles are always like 88 degrees, so it's almost like straight down. So just intuitively, it's never works out, right? But anyway, maybe we should jump back to the tree in the car.
Okay, so for the geometric analysis here, we have there's a systemic error that's present in all the measurements here, and it's that the globe misses their intersection angle by what they predict as drop over distance. And if you take the intersection differences from both our positions, from the rise over run to the peak and from the angle predicted at the observer, if you add those together, they end up canceling out. So it shows that the initial artifact of the rise over run condition set by the globe is the systemic error. If we go down here and look at what it would look like if the globe had the occlusions that correspond to that geometry, when you add the error to it, it would add to our error, and we would be off by the essentially the entire arc length, but specifically the rise over run to the arc. The drop over distance to the arc length. So because it's a elevation difference on a sphere, we would be off by that whole amount, but it actually cancels out in every measurement exactly. So another part of this is when we talk
1 minute remaining.
Thank you, sir. Now we're criticized for, you don't calculate for refraction. You don't account for refraction. Well, adding refraction exactly compensates for the drop over distance in every measurement, or it exceeds the amount of drop over distance by a factor of either 1.5 or times 6 in some cases. So in every scenario, when you go through these, you'll find that when they're always over, except for this case where the distance was extremely far. The refraction wasn't enough to compensate for the lift of it. But yeah, other than that, every single time it more than compensates for the drop over distance. So in other words, it's adding back what it took out as a correction for drop over distance. And then this also extends to the correction is so extreme that in some cases it even covers the entire central angle, and otherwise it's flattening out and recovering the flat earth angle. When per these theorems and postulates from Euclid, especially this tangent chord theorem, at the time of occlusion.
That's time. Go ahead and finish the thought.
Thank you. At the time of occlusion, when we add the arc length back, we should be off in elevation difference by the half gamma that we didn't account for. That drop over distance should be present in our overshooting of the elevation, but it's the opposite. The globe always overshoots. Thank you.
Thank you so much. And I also shared the link.
I measured the apparent elevation of this balloon from the Sunshine Skyway Bridge as it drifted east of me. The apparent elevation that I measured was 6 degrees. At about 150 kilometers distance, the flat Earth rise over run angle for the altitude of the balloon, which at this point was 17.3 kilometers, the predicted angle according to the rise over the run angle is 6.6 degrees. So the globe Earth with refraction again predicts about 6.01 degrees, which is within a tiny fraction of a degree of the prediction. It's dead on for the globe. So why is the flat Earth angle off by over half a degree, over the size of the full moon in the sky, and so high that it would have been completely outside the field of view of the telescope if I'd been pointing where the globe told me to point? And that's exactly what I did, and I found the balloon. Why is the balloon too low according to flat Earth?
Well, I'm going to have to look at the data. It seems like you didn't, make me privy to any of it, so I can't answer any of it adequately. This is all new. And it's a different methodology from what we actually do. So it's an all new thing that I'm going to have to analyze. And I look forward to going through it. And I hope that you can send me everything that you have, especially the ray tracing stuff. So I don't have an answer for you right now. It's the first time I'm seeing the data. You definitely should have shared this if you wanted to debate on it specifically. All of my data has been publicly available for the last 38 weeks. I do weekly streams on it. So all of it's there, and you had no problem accessing any of it because you went over it and accurately represented my position. So if you want to talk about the actual data from the actual method and how to falsify the null hypothesis through geometric intersection analysis, not adding a correction into it, then I'm more than happy to do that. So one of the things that you brought up specifically and repeatedly was that we're strawmanning the globe and yada yada. So let me screen share real quick, and we can go over a couple of measurements for what I said. I'm not strawmanning anything. So let me pull this up real quick. We can look at this. So allow. Okay. Should be live.
I'm not seeing it on my end.
Give me 1 second. Let me close and reopen thing. It could be a, dare I say, Linux issue.
I'm on Linux.
Oh, there it is.
There we go. You doubted the Linux too soon.
I know. Please forgive me. I've sinned or whatever.
Only this one time. Go ahead.
All right, thank you, sir. Okay, so for Pikes Peak, there's a predicted 201 drop over distance here. For the astronomical refraction added in, it lifts up 297 meters. So it completely compensates for the drop over distance as an apparent effect. Now, again, geometrically, like we went over through chord tangent theorem, that's just recovering the flat Earth baseline that's taking out what was put in as a correction. It was stated earlier that my model doesn't assume things or whatever. Well, it certainly does. It assumes that the baseline from a tangent is deviated by the drop over distance of a sphere of radius r, which is defined by the celestial sphere as well. So you can assume the equivalence between the two, and there's no difference. And because it's tied to a fictitious observer at the center of Earth, it's not mutually exclusive to bind that linear rate. That's actually what we're testing, is that 60 nautical mile per degree linear rate. When we go to distances that are extreme here, so we have 130 kilometers from Pikes Peak. I'm sorry, for North Peak. We missed ours by 13 arc minutes. The globe missed theirs by 21. That's 1,300 meters of drop over distance there, and they didn't. But it's all over the same arc length. So what happened in there obviously was the lingering, which creates that difference between the two, but still has to split it back to the globe like we looked at earlier on the SE Varley measurement. So that air difference, because the arc length of the star's position is changed relative to the original arc length, that's what produces the intersection air difference over that same arc length. So the star did occlude at the rise over run at the peak over the flat Earth angle, and to try to accommodate for that, all this refraction is added in to compensate for 35 arc minutes of drop, and with that, it would still be 3 arc minutes above the peak at the time of occlusion. Or no, wait, for positive, it would be positive is below the peak. Sorry, or no, that's negative. So yeah, for negative, it would still be above the peak at the time of occlusion by 3 arc minutes. So you talked about how the apparent position has to, be below the physical position, or even the apparent position as well. Well, if you add terrestrial refraction from that to the peak as well, the star is still geometrically over by, it's geometrically over with its apparent position by 2 arc minutes. So it's still, so in every scenario, you have to say that there was the exact amount of refraction to recover the flat Earth angle. And that's exactly what's shown in every single one of these. Blodgett Peak, there's 100 meters of drop. They assume 200 meters of lift. It's like every time over the same central angle. None of that is being addressed. So if you recover the flat Earth angle, you're not falsifying the null hypothesis. You're adding 2 corrections to the model. 1 correction for the deviation from a plane, that's the Earth curvature. That's what creates this central angle deviation proportional relationship to the chord tangent theorem. And when you add that back in, you're flattening that baseline. You're adjusting the timing difference to match what flat Earth predicts, because we predict the traversing the full arc length. So in every scenario, when you add refraction, it doesn't help anything.
Okay, so that was a lot of words to not answer my question, but okay, let's move on. The SE2 Varley, I'm glad you brought that up. The error you show there, including both astronomic and terrestrial refraction, is a bit larger than what I'm showing with my data. I get an error in terms of degrees of 0.014 degrees for this top one. This is the SE2 Varley observation, which is smaller than the celestial theodolite error. So again, globe wins on this one. The question is, which one better comports with reality? You're never going to get 0 error. You're going to have some variation, some error in the observation. With these observations, again, I am accounting for refraction as best I can based on conditions at the time using weather balloon data from that day. but it's not like these observations were put together and performed trying to time them as best as possible, as close as possible to the actual time of the balloon launch, obviously, nor were they strategically positioned to be as close as possible to the nearest balloon launch or anything like that, right? So the balloons are launched at either 0 or 12 hours universal time, twice a day, essentially. This observation, for example, occurred at 7 hours universal time, so nowhere near the time of the balloon launch. But even so, taking that into account, I'm still able to get an error that is lower than celestial theodolite. So yeah, I'm able to show that the globe is the better fit. And when I do stats on this whole data set, what I see is very consistently and an extremely strong p-value of less than 0.001. To put that in perspective on a three-way interaction, I'm a scientist by trade. I'm not going to wave that around as, oh, you should believe me, I'm a scientist. But I'm just going to say that in the 20 years or so I've been doing science professionally, I have never, ever gotten that level of a p-value on a three-way interaction. Granted, I work in the biological sciences where the noise is naturally higher. But because of that, I'm intimately familiar with the fact that measurements have noise in them. And so it's rather telling that the data set yields a globe result with a stat value that literally can't show any higher significance than it already does with the mixed linear model that I'm doing, and shows that the globe is by far the better model with a better fit to the data. So the natural conclusion to that would be to reject the null hypothesis. That's what we would do in science. Now, what Alan is doing is trying to obfuscate with the geometric intersection, which is not when the actual occlusion timing happens. Now, his accounting for refraction, I guarantee you, it doesn't use ray tracing and it doesn't use the conditions that were actually present as close as possible to the observation at the various angle or the various altitudes that the balloon traveled through, which is what I've done, and that's why I'm able to get. That's probably at least part of why I'm able to get a lower error for the globe in my measurements based on the software that I was using. So again, if we look at the target height error with the balloon, we see, it goes sky high. These observations here are with airplanes. This is with what he's familiar with occultations of stars. And even here, it starts to get crazy with altitude variations from flat Earth to globe Earth, and the flat Earth error is approaching 500 meters. If the plane were actually 500 meters off of its actual altitude, planes would be running into each other a lot more often, and yet we don't see that happening. So with the balloon, he didn't give me an answer. He has no explanation for why it's so high here. But fundamentally, another aspect of all of this that is required to be able to even do any of this is to know the distances between points, the distance between the observer, the distance to the peak. Now, he's going to claim, I suspect, well, okay, I'll let him speak for himself. I won't say what he's going to claim, but I will ask him, for example, with this balloon observation, okay, so this balloon was due east of me. It was on the same line of latitude as I was here in Florida, and it was due east of me. We can go back to my spreadsheet here. I'll unhide these top rows that have balloon observations in them. And yeah, the balloon here was at the same latitude as the observer. The only difference was the longitude by that amount there. So, Alan, let me ask you, how would you find the distance to that balloon on the flat Earth? What would you use?
Would use what we're using for everything else. We would use Haversine.
Okay, so he would use Haversine. Well, that's the globe. So yeah,
can I respond to that directly, please?
Yeah, go ahead.
Sure. Yeah, so we're using that as the radius of the celestial sphere. Distances are calculated based off of the positions of the stars. That's what the Haversine method does. Here's the Wikipedia link for a guy who made a bunch of tables.
Hang on. Let me switch this around. All right, go ahead.
Gotcha. Just start referencing it. And like I said, because it's tied to a fictitious observer at the center of Earth, it's not mutually exclusive. So if we have a unit of meters as a ratio of a terrestrial meridian, and we're calculating distances between the changing positions of stars, we could use the same thing. It's not mutually exclusive. And the thing is that if it was mutually exclusive, when we do these occlusion analysis, we should never be able to exactly recover the flat Earth angle, and the optical refracted position of the occlusion timing shouldn't be such that it exactly compensates to match the flat Earth angle. That's preposterous. We should always be above it as per the chord tangent theorem because we didn't account for it. So that's my answer to that. You assert that it's the globe, but it's a numerical number that's used to use a internally consistent coordinate system that's self-referential. So I don't dispute the use of it.
Okay, so he doesn't dispute the use of it. He says it's not mutually exclusive. Let me ask you, Alan, is the North Pole at the center of your flat Earth?
Most likely, yeah.
Okay. And the lines of latitude, there's circular concentric circles around that North Pole? Is that fair to say? Okay. What's the distance between the North Pole and the equator in your model?
Well, if you calculate it out based off of latitude lines and positions of the stars, it comes out to like 6210 or something.
6210 what? Kilometers or miles?
Nautical miles, I think.
6210 nautical miles.
Something like that, yeah.
Okay, 6210 nautical miles, 2 kilometers. Let's see. Come on, Google. What is that in kilometers?
So to be clear, though, like we're debating the geometric intersection angles of the star occlusions, not distance discrepancies calculating positions of stars. Do we all agree that using Haversine, the distance to the peaks is agreeable? Like for Pikes Peak, that's 50,000.
Hold on. Let me. Before we run off, okay? You said 6210 nautical miles from pole to equator. Is that correct? Is that fair? Okay.
That's what it calculates out to be.
Okay. So 6210 nautical miles is 11,500.92 kilometers times 2. So that is the total radius, right? So flat Earth radius. Now let me share my screen.
The 6210 isn't a radius value, though. Like what you're doing is taking a geodesic. That's a curved line on the graticule. That's the longitude line's a curve. So it being flattened out doesn't represent.
It's fine.
It doesn't actually represent like the actual.
Hold on. Let me share my screen.
It's not a radius value for us.
I understand. But so I'm just trying to get back to, because I have my spreadsheet already set up. Okay, so I needed to put it in as a radius, but we're getting it back to the flat Earth. We're recovering the pole to equator value. That's what I'm actually using. Okay, so it gets back to that 11,500.9 kilometers. Okay, now I put in the latitude and longitude of the balloon here. My latitude and longitude, the balloon's latitude and longitude, using Euclidean geometry. The distance to that balloon, according to the value you just gave me for the North Pole to equator, that should be 211.417 kilometers. That's like 60 kilometers more than the Haversine. The flat Earth elevation angle for the balloon now drops because that distance has drastically increased. Now we're talking a flat Earth elevation level of 4.68636 degrees. We're talking about an elevation error of 1.32 degrees. We're talking about a flat Earth height target error now of 4.88 kilometers. So how'd that happen?
Well, it happened because you use something that's not a radius value as the radius.
It doesn't matter. It doesn't matter.
Okay, you can just put in whatever number you want whimsically. It absolutely matters. That's why
it does not matter.
Okay, if you look at my screen share real quick.
No, hold on. It doesn't matter.
Oh, hang on.
Before you share your screen, the only reason I was
Everyone stop. We're getting a little hot under the collar right here, so let's all calm down a bit, okay? All right, so what I'm going to do is I'm going to let Alan show his screen share first, then you can go Astronomy Live. All right, let's go. So Alan, I am showing your screen right now. Go ahead.
Thank you. Yeah, you're using a flattened out longitude line as a radius. That's an improper use of a longitude line. It's curved by definition. It can't be a radius. We're using the conceptual height altitude as the radius value to put in for the celestial sphere. These two things are equivalent here. Distance traveled on Earth would be the exact same. There would be no difference using these two. So this idea of using the calculated linear distance from the latitude lines to the equator to the North Pole isn't a radius value. So I reject that premise, and we need to get back to actually talking about the Theo, the occlusions, right? We're not disputing the distance to the mountain peaks, so we're in agreement that the celestial sphere Haversine can be used. So why doesn't that correspond to any occlusions that are derived from that celestial sphere when using it with the globe dimensions? Why are you always recovering the exact optical angle using refraction, which turns out to be a literal geometric correction, making it recovering the flat Earth angle? Like why are we doing this rigmarole over you misusing a radius value? Go ahead.
All right, so let me stop the screen share there. In Astronomy Live, you now have your screen share up. Go ahead.
So once again, the only reason I was putting in as a radius value is just because that's how I already configured the spreadsheet. But all I was doing was taking that value, dividing it by 2 to get back to what I was actually interested in, which was the flat Earth pole to equator value that he just told me. So with that value in place, we should have a distance to the balloon of 211.417 kilometers. He's claiming that we can just use Haversine. Well, the Haversine uses the globe. You've accepted the globe by using the Haversine. In reality, your flat Earth does not give the same distances, okay? The distances are all screwed up on flat Earth, which is why you have to use the Haversine and use the globe, because otherwise the distance to the mountain's wrong, and you could prove it just by driving your car there. So this is why he doesn't want to use this, because it gets the answer even more ridiculously wrong. But that is the natural consequence of assuming that the Earth is flat instead of a globe. He can try to obfuscate that all he wants, but that is the fact. But okay, let's give him the benefit of the Haversine then. I come back to this again, that the balloon, even if you use the Haversine distance, has a flat Earth rise over run angle that is 0.6 degrees too high for the flat Earth, and in perfect alignment, it turns out, with the measured angle that I have with the telescope, the globe actually matches that instead. So that's a problem for you. And yet that problem is a relationship of the distance of the balloon. Would you agree, Alan, that this is naturally going to happen the further I look at a balloon, and that if I look at a balloon closer, that the height error is going to come down? Would you agree with that?
I'd have to see it. Like what you're proposing, like I said, is all new stuff. It's a different variation of our method. I'll have to be looked at and carefully considered. Like, and honestly, I'm not like super opposed to it, like off first gander. So I will definitely look at it and see, get back to you on that. But that's an entirely separate debate. The celestial theodolite that we're talking about is the geometric intersections of terrestrial features, such as a mountain peak and the stars. So it's a slightly different topic. I would love to come back to this on a separate debate or something, but we should be debating the data that we're all familiar with over the last year. That's been publicly available for everyone. I can't really comment on this that much.
So he doesn't want to talk about my data because it's real bad for the flying Earth. I get it. But sorry, if you can share my screen again, Reds.
Well, what's really interesting about your data is that you've had it this whole time, didn't propose it to me, didn't say anything, didn't say, hey, I'm going to be proposing some new data. Do you want to look at it? You're using it as leverage of me not knowing it. And then me saying that, I need to look at it and to consider it. You're saying that that's like a weakness somehow. That's preposterous. So
this data is pretty fresh, actually. So the balloon data, for example, we got this month, and Reds can vouch for that. The thing is, if your model is robust, you should be able to explain the data. You should be able to take a look at it. And I encourage you to take a look at it and come up with an explanation for why this balloon seems to be 1.6 kilometers, almost 1.6 kilometers too low, according to Flat Earth, because that's the height error, 1.571 kilometers. And I'm asking you, if you think, if I were to go to the balloon and get much, much closer to it, would this height error come down? Would it seem to come into alignment with globe?
So I noticed that instead of actually debating the celestial theodolite, you introduced a new method on the fly here, first time revealing it to me, and then keep asking me questions about data about it that I'm not familiar with.
It's a distinction without a difference.
So real quick, if you want to talk about the celestial theodolite and the geometric intersections and adding refraction back and how that recovers the flat Earth angle, I'm all game. If you want to discuss a new thing, send me all your stuff, and then we'll reschedule a follow-up debate. I can't comment on this right now.
Again, the geometric intersection thing is a straw man. The globe doesn't predict that the occlusion will happen at a geometric intersection. It predicts that it'll happen when the apparent angle of the target, whether that be an airplane, a balloon, a mountaintop, matches the apparent angle of the star. So it's a distinction without a difference. I'm cutting out the middleman of having to do this based on timing by directly measuring the angle. But celestial theodolite fundamentally is about trying to get that angle. I'm just directly measuring the angle. So he won't answer.
Hold on, don't interrupt me. It's a completely different methodology, bro. We're using timing intervals to measure the angle, not assuming
to measure the angle
correctly.
Yeah, to measure the angle. It's a distinction without a difference. We're getting to an angle.
Over two. You're doing a different method, though.
It's a distinction without a difference.
I mean, says you.
Yeah,
says a guy who did a different thing.
I did the same thing as well with the airplanes. I did it with timing airplanes. Remember? So I timed occultations of stars by airplanes and saw the same relationship.
And do you remember what I said? We're going to have to take a look at that. It's new data. It's a new thing. That's all that can be ascertained from that.
Yeah. So, how's that occurring with your response to Earthly Skeptic, by the way?
Let me butt in here for a second. All right. So let's hypothetically just say that we would want to, or let me rephrase. Let me try again here. It seems to me like you're wanting to have another debate in the future. Is that where we're going with this, Alan?
If he wants to go over the data like in a fair manner, where I'm aware of what's being presented, yeah.
Okay, let me ask you this: what would be? I'm sorry. Go ahead.
I said everything I've been doing is publicly available for the last 38 weeks.
Okay, so now, of course, this is just a guess here, but how much time would you guess that you would need in order to go through the data and to be confident that you know everything that you need to know about it?
I couldn't tell you. That would depend on the individual, but he was so confident in it that he decided to debate me on it. But he offered the challenge of it. So I would assume that he did his homework and knew about this intersection stuff. He went over the intersection comparisons in his intro, so I know that he's aware of how the methodology works, but then to not go over any of the data or acknowledge it is preposterous. To say that we're strawmanning the globe with refraction, we account for refraction, and when we add it in, it recovers the flat Earth angle. So doesn't help at all. He just keeps saying that we're strawmanning it.
So what I'm hearing is that if we were to schedule another debate in the future, we would have to wait for some sort of scheduling from you after the fact. Is that fair to say?
Yeah, I could probably knock it out in like a month or so.
A month. Okay, that's why I wanted. So somewhere around a month. I'm more than happy to set that up again. But Astronomy Live, to that question, new data and that kind of thing. When you came up with this, how old is this data? How long have you had it?
So, like I was saying, the data, some of this is extremely fresh, as in this month, and it's taken me until basically now to complete the analysis of it. Literally, I've been working on it this week, making sure it is all correct. So the data is available in the link that I gave you, Reds, to post in the video description, including the source code for the ray tracer. And you can run it yourself. It's just a Python script thingy. And you can recapitulate the output, which I've got here. Again, some of this is extremely new. So the latest observation was February 9th, and it took until now to complete the analysis of that data and put together this presentation.
I got you. Okay, so what I'm hearing here is that Alan doesn't want to address it because as of right now, he's just not familiar with it. And it looks like with that, we are at an impasse as of right now. So what I'm going to do is I'm going to call it here. Let's go ahead and go to questions from the audience, and we will go from there. So for the first super chat, which I guess isn't really a question, it's more of an advertisement, but we'll go over it anyway after show on Yerba Mate Talks. Well, thank you. Okay, so
Alan, how far away is Polaris?
What do you mean?
According to your model, how far away is Polaris, roughly?
Oh, for the conceptual model that I showed you for the use of Haversine, we set the altitude to the same as the Earth's radius, the same way that the Earth does for celestial navigation.
Okay. What would you say if I said that I measured the distance to a geostationary satellite at something like 22,000 miles?
Say that again?
What would you say about me seeing a geostationary satellite that's about 22,000 miles away?
Well, I have contentions with the actual altitudes of the satellites because there are timing corrections involved in them, so I couldn't say for certain.
And see,
but I would expect though that it would be internally consistent with the coordinate system because the corrections that they make are timing corrections to the internal clock when it passes two GPS stations. So if there was any sort of data cooking or whatever, it would come out to be internally consistent. So,
well, see, I'm not relying on the internal clock of the satellite. I'm measuring the distance myself with two telescopes, parallax. Two telescopes far apart, finding the parallax to the satellite, determining what the distance of that satellite is with simultaneous observations.
Oh, I see. Yeah. So for that, I would say that that's an optical measurement. That's just optical effects. So plotting that is going to be internally consistent because the coordinate system itself is based off of that same radius. So
optical effects like refraction, right? That is it internally consistent, or maybe I'm basing it on weather balloon data where I'm ray tracing it based on the actual atmospheric conditions.
Are you aware that I'm not denying refraction exists? And what I'm saying is that it comes out to be a literal one-to-one geometric correction for the occlusion timings to offset it to make it match what Flat Earth predicts for the full central angle.
See, right there, he's attributing motive to it. That doesn't exist. There's no motive to it.
Can I show my screen real quick?
Sure. Hang on a second.
Whether or not a quote-unquote motive exists, geometrically, every time the refraction amount has to be cut off exactly to match the flat Earth rise over run angle for the occlusion. That's exactly what happens. That's not a motive. That's just what's happening as prescribed by the refraction corrections for the formula that are used when you're 10 degrees below the horizon. And for the record, the refraction formulas are not derived off of any experimental evidence. They're derived from watching circumpolar stars, and then they take the position of where they observe it versus where the position it should be in their coordinate system, and they say that's how much refraction it should be. So that's how we ended up with this curve-fitting scenario where at these angles to the horizon, the refraction amount exactly matches what the amount needs to be to have it still be visible and not be occluded by Earth curve. So when you talk about geometric intersections is a straw man of the globe, it's the baseline for when an object should be geometrically occluded by Earth curve. Like when the sun hits 0 on the celestial coordinates, it's at the equator, that's when it starts to get occluded by the Earth curve for you guys. That's the baseline for it. And then you say refraction changes the actual setting time. And what I'm saying is when you add the refraction prescribed in for these stars, in the same way for that 0 baseline to start with, for when it should be occluded for the globe, it literally recovers the flat Earth geometry. All you've replied with so far is just pure rhetoric. You haven't addressed this at all.
I've absolutely addressed it.
At one point in the debate, you went on to monologue about Shane for 5 minutes.
Hang on 1 second. Okay. Astronomy Live, I see that you might be screen sharing something. Do you want me to show it?
Yes, please.
Okay, let me bring that up, and you may go.
So he just said, I heard him say it, that refraction isn't based on experimental evidence. It absolutely is. And it is, especially in this case. All of this data where the globe is taking into account refraction is absolutely based on experimental evidence. It's based on weather balloon data from each one of these observations. I excluded observations if there wasn't a valid weather balloon, okay? There was only a few of them like this, but for example, if the observer happens to be lower in altitude by a significant amount than the nearest weather balloon launch, and the nearest weather balloon launch is, hundreds of miles away, that's not valid. So we're just not going to use that. I used exclusively experimental data to calculate for refraction here to find the prediction and the error, both in my observations that he doesn't want to talk about and in his observations. And guess what? The globe is better, and the globe ends up fitting far better with lower error. Here's what he said about that, by the way.
How much non-flatness would the celestial theodolite angle have to show in order to refute the null hypothesis, or is it irrefutable, like unfalsifiable?
No, as I said earlier, if these air offsets were reversed, the Earth would be a globe. It would be the direct implication. The null hypothesis would be falsified if the airs were reversed. It would be so goddamn conclusive, I would be here arguing against all the flat earthers.
So, according to Alan, he should be arguing against all the flat earthers now after tonight, because even just looking at his observations, the globe error is lower. Congratulations. Turns out Earth's a globe. And furthermore, as far as geometric intersections go, again, I'll show this screen again. The prediction isn't that the star will disappear when it's geometrically obscured. It doesn't matter what the geometric intersection is. It doesn't matter when that star is occluded geometrically. That's not what's going to determine the actual occlusion time. It's going to be based on the apparent position of the star because of refraction, just like we see in this water tank example. When water is in the tank with a significant salt gradient producing a density gradient, and you see that bending of light, you see the vertical compression of the black thumb screw, just like you would see with the moon or the sun low on the horizon, we see that the star is visible above old SpongeBob here. And then when we get rid of the water, suddenly that star is not visible anymore. In fact, you can even see the seam at the bottom of the tank down here. That black seam is risen partially above SpongeBob here. That's how significant the refraction is here. So yeah, refraction matters, and you have to take that into account. By not taking it into account and by focusing on a geometric intersection, you are by definition strawmanning the globe and continuing to lie about it.
All right. And Alan, I'm going to give you the last word on that, because then we got to get to the next super chat. If you can, try to keep it short, but say what you got to say.
Yeah, let me screen share real quick, because there's actually a lot to go in there. And playing a voice clip out of context is one of the grossest things you can do in a debate. What I said was talking about the geometric intersection comparisons, and your data isn't even doing that. You're doing refraction apparent positions, completely separate thing. So to use my quote about geometric intersections and to apply it to a different data set and accounting for not geometric intersections is a preposterous thing. Now, you keep saying that when the apparent position is lower than the object, that's when it gets occluded. But in no case have you addressed that in every scenario at the time of occlusion, the apparent position for the amount of prescribed refraction is over the peak that's predicted for the globe. So it would result in the star lingering above the peak. None of that ever happens. That hasn't been addressed at all. You keep saying that I'm not accounting for it. To account for it, not only am I doing that, but you have to also cut off the remaining amount and say that it just fixed the 11 arc minute difference to match the timing offset, which recovers the flat Earth angle. So you're proposing using the optical, what we see, as proof of the globe rather than the geometric when you use the refraction positions. So if you're 2 arc minutes above the peak, then that's not an occlusion. You would have to wait 10 more seconds before it occludes.
Can I respond real quick?
Actually, no, you can't, because we got to get to the other super chats. I'm sorry, Astronomy Live, please forgive me. So next super chat again from Earthly Skeptic. Thank you very much again, $5. Alan, you say a line from the center of a circle to a point on the circle on a flat plane is not a radius ? Come on, don't know Euclidean geometry ? Go ahead.
It's a flattened out line on an AE map is a longitude line. It's part of the graticule. It's a spherical coordinate system. It's curved by definition. A radius is a straight line. They're definitionally different things. Not being able to differentiate that is not my problem.
All right. And Astronomy Live, do you have anything about that in particular?
Not that in particular. I'll leave it.
Perfect. I appreciate it. Thank you. Okay. Again, from Earthly Skeptic for $5 more. Thank you again. How much would the star's angle change if the distance to the star is off by 6 kilometers? Show a calculation for 39 Aquarii / Pikes Peak. And just so that we're clear, it's 39 AQUARII, because I butchered the pronunciation of that.
You're good. What was the question? He wants me to add 6 kilometers to the measurement. Is that what he said?
What I will do is in the internal chat, I'm going to copy and paste it right there. How much would the star's angle change if the distance to the star is off by 6 kilometers? ? Show a calculation for 39, whatever the fuck the star's name is in Pikes Peak.
Gotcha. So if we just add a 6 to the 50,000, I think that's not going to change the angle. It would change by 1 1 arc minute per kilometer, right? Like something like that. So like 1 nautical mile per kilometer, or 1 nautical mile per arc minute. So I don't know, whatever that would be. I'm not sure the purpose of the question, what it's supposed to show. The change would occur on both models. I don't know what I don't understand the point. Like what he's trying to get at.
All right. Astronomy Lab, do you have anything to say in regards to that question?
I'm wondering if he meant to say the distance to the peak instead of the distance to the star, but I don't want to assume for him.
Understood. If that is what you were trying to ask, you can always ask it again, or rephrase it, and I'll find it. Maybe, kinda. No promises. Unfornicated for $5. Thank you so much. Alan, do you still maintain the claim that star mountain observer are in geometrically straight line at the time occlusions are observed?
So the observer would see the apparent position, but the geometric alignment at the time of occlusion, when you add the arc length back, that is the implication. It makes a congruent triangle to the peak. And on a globe, we should be off by the elevation that we didn't account for. We should be above the peak by 13 arc minutes in the case of Pike's Peak. Like when I showed earlier, since I have it up, let me just show it real quick. So this is what was measured geometrically. And then if the Earth were a globe, if we change it to what the globe, if they had their ideal intersection, it would reverse that. So we would be off by 13. So.
All right, Astronomy Lab, do you have anything to say in regards to that?
The implication of what he just said is that he's strawmanning the globe by saying that when the geometric lineup happens between the peak and the star, then yes, the star should disappear even though the apparent angle would be higher than the geometric angle. So it would just vanish in the sky well above the peak by whatever the amount of refraction is. The refraction difference between the peak and the star, obviously that doesn't happen, but that's a straw man of the globe. That's not what the globe predicts. The globe predicts that the occultation happens when the apparent angle of the star matches the apparent angle of the peak. And if you share my screen real quick, again, looking at the elevation angle error between flat Earth and globe, the globe oscillates on either side of 0. The flat Earth oscillates, but a lot more. The error is higher, both positive and negative, on the celestial theodolite method because it's broken. It doesn't work. It doesn't match reality.
All right, and we're going to double back to a previous question because there was a typo. So thank you very much for retyping it. I found it again. If the distance to the Pike's Peak is erroneous by 6 kilometers, how much would the elevation angle to 39 Aquarii change?
Well, it's not erroneous. It would change it by whatever the nautical mile per arc minute comes out to be over that. So it would change it by that.
All right, understood. Astronomy Live, anything to say in regards to that?
Not really.
All right, sounds good. All right, for $5, DP debunks. Thank you very much. What if Astronomy Live renames the planes/balloons as mountains? Will that help? Because that's basically what he's done. It's not that hard. So Astronomy Live, I guess what he's trying to say is what you did is directly analogous. Would you agree with that?
Yeah, I mean, so I specifically did the airplanes thing, right? Making sure to do the star, catching them going over stars, because I knew, like, I could have done this with just astrometry, right? And measured the position of the plane over multiple points in the video. Would have given me way more data points, would have looked more impressive, but he would have objected to that because, oh, it's not in front of a star in that moment. Okay, fine. Here, I'll find you some that it's in front of the star. Specifically to address that comment. And sure enough, even just based on that data, yeah, the celestial theodolite starts falling apart when the plane gets, significantly far away at a high altitude. But then to address something else that he's been asked to do for a while now, he's talked about 38 weeks he's been doing this. Well, for a lot of that, he's been asked, just measure the angle to Pike's Peak directly. Use an actual theodolite and measure the angle to Pike's Peak, see if there's globe drop, So, okay, let's do that, but let's also pick a target that is significantly higher than Pike's Peak, significantly farther away than Pike's Peak, where atmospheric refraction is less of a factor, so we don't have to be worried about that so much. And let's see which one holds up. And for that, we have the balloon. Again, about 150 kilometers at its greatest distance in this video, and measuring its position over multiple points in time, we see, oh, look, the trend continues, and we've directly measured the angle. The only difference here is he's trying to get to the angle using occlusion timings. I'm just skipping straight to it here, which is what he's been asked to do for a while now and hasn't done. Well, I did it. And look, it's a disaster for flat Earth. It matches the globe, and it absolutely contradicts flat Earth. It absolutely refutes the null hypothesis, and I'm curious to see where he goes with that. Again, the data will all be available in the video description. The source code is available at the GitHub in the video description. Happy to have another discussion with him later once he's had a chance to review it. But again, this data is fresh. I literally was working on this right up until yesterday, getting all of this prepared and ready.
All right. And now for you, Ellen, same question, but let me just ask you directly. Do you believe that the balloons and the planes is analogous to the peaks of mountains?
It certainly could be. We need to go over certain aspects of like how we determined, the position and stuff over time, how we can guarantee 1 second accuracy over it. There's things to discuss over it for sure. It could be. Like I said, when he initially proposed it, I got really excited because I thought it was really cool, and I look forward to going through it.
Understood. All right, Earthly Skeptic for $2. Thank you very much again. Why didn't you include radius of vision in the celestial theodolite?
I did when I said that I was deriving distances based off of a celestial sphere with radius r. That's a conceptual model that represents your radius of vision.
Astronomy Live, do you have anything to say in regards to that?
I'm sorry. He's basically saying that it's going to look like a globe, guys, because of radius of vision. It's going to look like a globe, but it's going to match the Haber sign. So when you're supposed to be, in South America and you can't see Polaris, that's why. It's not because Earth's a globe. Totally not because Earth's a globe, guys.
Well, on the reverse, you're actually saying that it optically looks like a globe while recovering the flat Earth angle geometrically. So you're saying it's geometrically flat, but it looks like a globe. That's actually your position, not mine.
It doesn't look geometrically flat to me.
Yeah, based off of not doing a geometric analysis. Unlucky.
Again, if you take out the refraction here, the refraction is a tiny amount of the delta here. Even if you acted like this was just a purely geometric angle and you disregarded refraction, well, you still got a huge problem because globe still beats flat Earth by a handy margin.
Oh, if we look at this new data set using different methods and stuff, we can... Come on, guy.
Direct measurement of the elevation angle, which is what you were asked to do.
That's not what we... That's not, has nothing...
It absolutely has everything to do with it. You're trying to get the elevation angle.
First of all, just looking and taking the measurement of the optical angle is self-referential. But the whole coordinate system, everything is all based off of what it appears to be. We're actually geometrically testing it with occlusion timings. You're pointing at an optical measuring device.
I'm pointing at an altitude circle that has degree markings on it. It's a circle, and it marks off the degrees. You're claiming it's self-referential? No, it's not. This is an elevation measurement directly with the telescope. It's not self-referential, okay? And
position
this tells me the elevation of what it's pointing at.
The optical angle that it's going to be is going to come out. That's the self-referential part. It's going to match exactly the optical angle to it.
So you're saying that, because of refraction, it's going to match. Well, I got news for you. Refraction here is a tiny portion of the error. So even if I disregard refraction and treat it as geometric with these observations, you still got a huge problem. Yeah, it makes the globe result a little worse because the refraction actually does matter. But even if I disregard it, you still got a big problem here. Yeah.
The big problem is didn't use our method, use different stuff, introduced a new thing. So it'll take time to go over that and get back to you on it.
It's a distinction without a difference because you're still trying to get to that angle. You're just using timing of stars behind the object to try to find the angle. I just measured the angle directly. As you'd like to point out about the model with fewer assumptions. Well, guess what? Doing it this way with the telescope and directly measuring the angle, that's got fewer assumptions. But that's not why I'm saying this is superior. I'm saying that this is superior because it's a target that is higher in altitude, further away, where the two models are going to predict a bigger difference. And they do. And what we see is the results match the globe.
I can't wait to do the follow-up analysis and look and see your data.
All right. Excellent. Let's go ahead and move on. Also, someone said in the live chat, at Ritz you don't need to emphasize the tick at the end of my username. YouTube just didn't have Earthly Skeptic available. Okay, well, thank you for that correction. I will be sure to put even more emphasis on it just to be annoying. So with that, let's go ahead and continue. Deplorable Ilk for £5 says, can Alan explain how Haversine and flat Earth distances are the same? His flat Earth map is the AE map, is it not? ?
Well, the AE map is just a projection of the graticule, which is a spherical coordinate system that is latitude and longitude, which is dependent on the position of the stars at the first point of Aries, and then deviations from that are referenced to determine, how the star changes over distance. There is no difference in what flat Earth would predict. And if you could show my screen real quick, I had the equivalent there showing the same thing for a drop of the stars, assuming the same altitude. So using the Haversine is just the change in position over stars. That's what it's calculating. That happens on both models. One is assuming that it's a linear rate though. And when we get to the horizon, that's what we find, that it's not a linear rate. The intersections show that there's a deviation from the celestial sphere. And geometrically, for the true positions, there can't be any deviations like that because the globe is dictating the change in position of them. So there shouldn't be any discrepancy for the true positions in the way that it's showing up in the occlusions if they're truly following that linear rate. It's just used as the baseline for the calculation. And when using it, with respect to the coordinate system itself, it'll always be internally consistent. So.
All right. And Astronomy Live, unless you have something else to add to that, I'm going to get to Slice Arcane next.
No, that's fine. You can just go to Sly.
Okay, Slice Arcane for $6.66. Nice. He says the following: what flat Earth angle, question mark, in all caps? I presented a similar argument regarding angles to Alan at his request, and he went silent weeks ago. I guess the question is, are you planning on getting back to Slice Arcane anytime soon?
Absolutely. I told him specifically that I don't get Twitter notifications, and that if he wants me to address something directly, all he has to do is DM me. He's never messaged me once. I have no idea what he's like. What I'd be happy to look at it, but I don't know what he's referring to. And I told him the best way to contact me. I even invited him to our Discord, and he said no thanks. So,
understood. All right, Earth is Life for $5 says, Alan, where are the stars 6 hours after they've been occluded according to Stellarium?
According to Stellarium, they would be under the globe.
All right. Astronomy Live, anything to add to that?
No.
Okay, cool. Earthly Skeptic. I'm sorry, hang on a second. Earthly Skeptic. Did I do it right? Hopefully. Alan, Christ. Okay. Haberstein calculates that longitude converge, not diverge, south of the equator. It also calculates South Pole has 0 diameter. Do you agree? Question mark.
It is a conceptual model, and when you when both hemispheres are represented, that's what it would calculate out to. I agree that that's what it calculates out to.
All right. And Deplorable Ilk for £5. Again, thank you very much. I really do appreciate it. If Alan is so upfront and honest, why does he block people on Facebook who challenge his claims?
I don't have a Facebook, so I don't know who that person is or who they've tried to talk to me. I run a show every week where people can come and talk about celestial theodolite stuff, raise their contentions, etc. It's hosted on the Earth Awakenings Discord. So I don't know who that person is. They could try contacting me on Twitter. Sometimes I get the notification, sometimes I don't. But just follow me and send me a DM, or you can come by the Discord. It's discord.gg/ethercosmology.
And you're okay if I post a link to that in the description?
Sure. Yeah, everyone is welcome. There is a code of conduct. You can't come and just endlessly argue over nothing. But it's more like a research focused place. It's, so that's it.
Understood. Okay. So what I'll do after the show has concluded is I'll go ahead and put all these links down below, which will include a link to that Discord server. I believe those links expire after a certain period of time, if that's how it works. Is this one of those links?
No,
it's permanent one. Perfect. Okay, cool. That means I don't have to update a damn thing because I am lazy. Okay, so Flattest Earth for $9.99 says the following. Alan, in your assumptions, I screenshotted a flat Earth dome height of 6,371 kilometers. How does this contrast with space is fake, question mark, no spaces there. Astronomy Live, did you catch the Freudian slip of motive?
The Freudian slip of motive. Not sure what I means by that.
Yeah, neither do I. So, Flaudius Earth, I'm just going to skip that part. And also because I can't speak for some fucking reason right now, that is my fault entirely. But let's revisit the first part. Alan, in your assumptions, I screenshot a flat Earth dome height of 6,371 kilometers. How does this contrast with space is fake? I'm guessing that's a user on Twitter.
Yeah, I'm not sure. I think his question, though, was how do we come up with using the radius value? You can derive it just from the change in position of the sun or moon over distance and derive the slope of that and get pretty much the same radius value. So if that was kind of the question, then that's the answer. If that wasn't the question, I have no idea.
All right. Understood. Fair enough. Let's go. Beasticles, if that's how that's pronounced, for $9.99. Thank you very much. Can you go over one observation and show how, 1, where the globe is strawmanned, and 2, can Astronomy Live explain celestial refraction and how it's incorporated? Question mark.
Sure.
So that's for you, Astronomy Live. And to make sure that it's not missed, I'm going to copy and paste the question in the internal chat.
Okay. So if you can share my screen for a moment.
Yes, let me do that real quick.
So again, the straw manning comes in that he keeps talking about geometric intersections. That doesn't matter. That's not what the globe predicts for when occultations and occlusions of stars by mountains or other objects will happen. It's when the apparent angle of the object matches the apparent angle of the star. Now, in terms of how I'm calculating celestial refraction, that's based, in my case, on ray tracing, based on weather balloon data taken from the night of the observation. So I grab the weather balloon data, I get the profile for the temperature, the humidity, the pressure at the various altitudes the balloon's at, and I'm using that to conduct ray tracing through that atmosphere and see how well that matches with the observations. And it ends up matching quite well. The error floats around 0. The statistical significance is extremely high, less than 0.001 in terms of the three-way interaction between the model, whether that's flat or globe, the distance of the target, and the height of the target. Those are all highly, highly significant because, again, if you look at the pork chop plot, the globe predicts that, yes, celestial theodolite looks like it'll work pretty well around low altitudes compared to a weather balloon, or distances that are lower than, say, 150 kilometers to a weather balloon. And when you get into those kinds of distances and altitudes, things get real bad, up to 0.6. Well, guess what we saw with the weather balloon? 0.6.
And to the second part of the question, which is, where is the globe strawmanned? I'm assuming it was when Alan was going over his presentation. There was a part during that presentation where you said that Alan was strawmanning. Can you highlight exactly what was being strawmanned and how?
Oh yeah, all throughout he keeps talking about geometric intersection and trying to make that the argument. By its nature, that is the straw man. When he complained about that clip I played of him saying that if the errors were lower, he would be a glober, he's saying that because he's trying to strawman the issue to be geometric intersection, and that if the errors were lower only under geometric intersection, then he would be a glober. Well, that's a straw man of the globe. The globe's not predicting that it should work right if you're trying to use geometric intersection. You have to use the apparent angle. The apparent angle does match. And if you get into targets and distances that are quite high, you can get to the point where refraction doesn't even matter that much. You can take it out and you start looking at observations like this. Even if you exclude refraction, the globe's still going to win by a country mile. So by all rights, he ought to be a glober tonight, and he's not. That's because he's dishonest and he's strawmanning the globe.
All right. And Alan, I'll give you a chance to respond to that. Go ahead.
Dude, framing my position as being dishonest when I haven't had a chance to look at your actual data methodology used to confirm everything is insane. And it shows a lot of weakness. Now, if you can bring up my screen real quick, I'd like to show the refraction corrections. So the question specifically was about astronomical refraction in regards to how they determined the values for astronomical refraction from a paper here from, what was it, from this Willis guy, from John Willis, a determination of astronomical refraction in physical processing. What they did to get the refraction values is they watched circumpolar stars at low elevation angles and it just calculated where it should be versus what they observed. And then from that came formulaic outputs where at the lower elevation angles, based off of the air density from their circumpolar observations, they come out with these formulaic outputs. Now, when we compare the refracted position in every time, it geometrically recovers this the flat Earth angle that I was showing earlier with the tangent chord theorem. So the position is, it optically looks like a globe, but geometrically it's flat. This is never addressed in any of the debate so far. It's always about different things and then introducing a new methodology, which was already stated to be admittedly different, but accomplishing the same goal, so therefore indistinguishable. Absolutely not. One's using timing intervals to measure physical geometry, the other is using apparent angles. So like I said, I will look at your data and go through it, and I will see if you properly did the flat Earth predictions, and we'll go through it from there when we get to it. So framing it as being dishonest is, insane at this point. I can't agree to look at your information any harder than I already have.
Okay, so yeah, it is, you are being quite dishonest because you know for a fact that I'm not doing it based on circumpolar stars. I'm doing refraction based on ray tracing from the weather balloon data. So to answer the question from the super chat, that's how I'm doing it. I'm doing it based on experimental data from the weather balloon to basically determine what the refraction should be based on the actual conditions at the time of observation from a weather balloon as close to the observation as possible. And what we see when we do that is we see errors for the globe that are lower than that for celestial theodolite.
All right, I'm going to go on to the next one, and it's going to be from Brian Peck 108 for $5. Thank you very much. Considering you also use the Bislin model for light paths, you're off by dozens of degrees at minimum, aren't you, Alan? Question mark.
I have no idea what that even means.
I'm guessing what they're, this is purely an assumption on my part, and I could totally be wrong on this, and that's okay. I acknowledged it. But I think they're saying, is there any overlap between the Bislin model and the celestial theodolite? Is there any overlap? Is there any information that both of these things agree on? Like, is there a data point that you could show with the Bislin model that would agree with the celestial theodolite?
I don't know that you could put in specific data points into the Bislin thing. So I don't know. But visually, it just represents the conceptual model of the observer-centric observer, and how he would see it in a limited vision with respect to objects circling above him and how he would perceive it versus where they are in 3D space. So, conceptually it's used for that, but I don't know that you can plug in specific data points like that.
Understood. All right, for 5 pounds, Deplorable Ilk says, if optical angles are self-referential, how does or why does Alan use optical angle measurements?
We use a timing interval when the star was occluded in reference where it should be at that time, using the baseline of the linearized 60 nautical miles per degree at sidereal time. So.
All right, Astronomy Live, do you have anything to say?
Yeah, he's trying to infer the angle, and what he doesn't realize is the optical angle is what matters here. It's about the apparent position of the star and the mountain, and he keeps referring to the geometric intersection, which again is a straw man of the globe. That's not when the occultation will occur. So he's trying to infer the angle based on the timing, but ultimately what he's actually producing is the time that the star was actually occluded, which is because of the apparent position of the star and the mountain.
All right, Alan, go ahead.
And real quick, let me just add to that. That's not true at all, because in every case where the star is still above the peak, there's no lingering, so that's not the actual amount of refraction. You have to literally cut it off to be exact. You keep not addressing that while simultaneously saying that it would still be above it. When we reference any measurement, though, where it's still above the peak, there's no answer to it. It just remains silent.
Again, if you show my screen,
Yep, hang on. I'm getting to it.
The globe air oscillates on either side of zero. There's obviously going to be noise in the data. Sometimes globe predicts the star should have already set. Sometimes the globe predicts the star shouldn't have quite set yet. But in general, the point is that the error on average and with the root mean square error is lower for the globe. Again, the root mean square error for the globe here is 6 times, the flat earth error is 6 times the globe error. Okay, and that's with me excluding the weather balloon observations he doesn't like, right? That's just looking at the occultations of the airplanes and the mountains. Put all that together, the root mean square error of the flat earth, the celestial theodolite model, is 6 times higher than the globe. And the globe isn't just like, I guess he's trying to act like the globe always shows the star as on one side of the mountain, like it's still above the mountain and we cut it off. No, the error fluctuates on either side of zero here when you properly account for it like I have.
If the error fluctuates on either side of zero, you're rounding it off to be exactly what the occlusion angle would be for flat Earth over that timing difference. You're basically delaying the occlusion with refraction, and it just so happens to match the flat Earth angle in every single case geometrically. So you're arguing for an apparent globe versus a geometric globe, which is unfortunate, because if the globe isn't a geometric fact, then it's not real.
Again, he's ascribing some motive there that doesn't exist. This isn't biased data. This is based on weather balloon and ray tracing data. So it is what it is. It falls where it falls. And where it falls is the globe has far better predictive capability and comports with reality better than the celestial theodolite.
All right, we're going to move on. CK, thank you very much for $4.99. Actually, before I get there, let me go ahead and say the last super chat I see is from Beasticles for actually, no, scratch that. It's from Deplorable Ilk for £5. And so here's the thing. I love money. Money is great. Money is actually the answer to all of my problems. Any problem that I have can instantly be solved with money. I'm going to ask you to stop giving me so many goddamn super chats because we got to get to the end of this shit at some point. Okay, so Deplorable Ilk for £5, just underneath from Jess for another $5. Those 2 super chats, I made notes of it. Those are going to be the last super chats that I read. So if you send any more super chats, you're just wasting your money. Now, by the way, check out Louis Rossman's most recent video. Worth a watch. Anyway, moving on. Jack Fetter for $9.99. Months ago, MC Toon pointed out the error rate increasing wildly with distance, and the presented data was essentially cherry-picked. The answer was, I need to look at the data. Nothing has changed. So, Alan, I believe that's towards you.
Oh, absolutely. A ton has changed. So if you can bring up my screen real quick.
Yes, hang on 1 second.
Yeah. So all right, as I said earlier, we're sharing the same celestial sphere model, the same assumptive linear rates and whatnot. So if those rates don't correspond to reality, it's going to create a systemic error offset. And through the geometric analysis, after learning about central angle theorem, inscribed angle theorem, and tangent chord theorem, what we found is like this exact relationship has to do with the lingering effect over the arc length. So earlier when I pointed out the differences on North Peak, for example, we have these pretty big errors, right? But they're split over the timing difference that the star lingered to. Essentially what that equates to is more time, so more distance traversed. So the star has a different arc length compared to the one that we're using. So that's what creates the difference calculated when you reference the true position at the peak versus the true position at the observer position. But what you'll notice is that if you subtract these two from one another, or I'm sorry, if you add them together, they equal the drop over distance, like it's shared between us, but the offset is split over the exaggerated arc length rather than the arc length that we're doing the analysis over. So that's why we get like larger numbers in the offset. But that is it's fine. I mean, that's showing up. It's part of a geometric theorem from Euclid from, you know, however long ago that dude wrote those, and it's showing up in the measurements. It's pretty cool. So like the example that I went over with S.E. Varley, it's really easy to understand what I'm talking about because the arc length here is 9 arc minutes over the distance. And because the star lingered in an additional 4 arc minutes over that arc length, the globe ended up being off by twice the amount of the original drop over distance, which happened to be the amount that the star lingered over the original arc length of 9 arc minutes. So rather than lining up exactly, that's what creates the offsets in the data for the overshoots. But the occlusions are still happening when the star intersects, when its true position intersects with the mountain peak. That's why every time when we do the refraction analysis, you know, the globe or the flat Earth ends up recovering its geometric angle when you add that correction back in. So they end up being identical.
All right, and we will move on. This one is just an insult. Just going to throw that out there, but I'm going to read it anyway because it's a super. I'm going to read it anyway because it's a super chat, and I have to. For $1.99, Kenny Eaton 603. Hi, Kenny. Also known as It's Not Flat. Why is Alan still this incompetent in 2026? You don't have to respond to that if you don't want to. You can if you want. I don't care. I'll give you the opportunity.
It seems like somebody super chatted you to not talk about the geometric intersections again.
Excellent. Flatius Earth for $1.99. Astronomy Live, why don't you just let the top lefter strawman?
Why don't I just what?
Why don't you just let the top lefter strawman? I guess they're asking why even bother, I think.
Oh, well, that's fair. For the love of the game. No, let me. No,
that's
seriously.
It, that's it, though, really, isn't it, though? It's the love of the game, dude. Like, you think you're right, I think I'm right. We're going to battle it out. It's the love of the game.
No, here's the brass tacks truth of it. Like, I enjoy conducting challenging observations with my scopes, especially. And this was an opportunity to do something new and challenging that I'd never done before, which is receive ADS-B data directly from airplanes instead of just, going online to see what the website, the flight trackers say. No, get the data directly down from the airplane with an antenna, get into amateur radio with RTL SDRs, and then using that also receive the data directly from weather balloons. And so get the coordinates and the altitude of weather balloon, track it from 150 kilometers away. I mean, it took a massive telescope to do that over that kind of distance. And it didn't even show up in the finder camera. Like, it showed up because I was pointing right at it, right where the globe said it should be, not at all where Flat Earth said it should be, and it worked. To me, that's wonderful. That is science in action. That is predictions matching reality.
Excellent. All right, so we're going to move on. Hang on one second. Let me just get rid of that. Okay, so for $2 from Icy Spin says the following: where does the sun go at night? So, Astronomy Live, where does the sun go at night?
Well, it goes to the other side of the Earth, away from you. The Earth rotates, now it's facing the other side of the Earth.
And Alan, where does the sun go at night?
It goes to sleep.
Goes to sleep. All right, understood. Okay, so from just $2, Astronomy Live, did Alan contradict himself on refraction?
Well, okay, so I have issues with how Alan describes refraction because he is ascribing motives to it and talking about historically how it was determined using circumpolar stars, ignoring my method of doing it using ray tracing and weather balloons. I just fundamentally have a problem with that.
Understood.
Well, we're using,
go ahead, Alan.
Real quick, if I may, we're using vastly different elevation angles. The refraction formulas for elevations below 15 degrees are the ones that specifically are based off of the curve fitting, essentially. So just wanted to.
And again, I'm not using any of that.
And again, you're doing a different method, doing a different comparison, trying to achieve the same goal, not doing the celestial theodolite. When we do the celestial theodolite, this is what we're dealing with.
Again, this is all celestial theodolite right here. That's what this is. I'm doing the globe prediction based on the actual globe, and actually based on the atmosphere, not based on some polynomial from 100 years ago. I'm doing it based on weather balloon data from the night of the observation to do ray tracing and determine what the actual apparent angle of the plane should be and of the star.
Fantastic. I can't wait to go over it.
Excellent. All right. Deplorable Ilk for £2. There wasn't any message attached to the super chat, so I'm just going to say thanks. So then we have Brett Immus _118 for $5. Astronomy Live, how did you determine that your eclipse path 1,000 years from now was an accurate prediction? ?
Well, ultimately, I won't be around in 1,000 years, right? But maybe YouTube will, and we'll see. But it matches if you if you go to other less well-known sites that have Besselian elements for that observation, I discovered that after the fact, but yeah, it matches. And the method I use, which I featured in that video, is based on the orbital elements of Earth and the Moon. And I determined that independently, not based on the 5 millennium canon of eclipses, not based on anyone else's website, just based on the orbit of the Earth and Moon. So go check out that video. It's on Red's Rhetoric's channel here. I brought it up only because Alan brought up Besselian elements and eclipses, and I just thought that was kind of ironic since I've got a whole video about that on this channel.
Understood. Real Cygnus for $5 says, the Laddie, Longy, and Grady were all in the Prezi, but what about the Kinney, Matties, Broad Dog? Jesus fucking Christ, Real Cygnus. You're going to fucking kill me with this shit. Oh, God.
The kinematics and the dynamies?
Yeah, you know what? I'm just going to copy and paste it. If you want to reply to this, by all means, be my fucking guest. Reading that, I practically thought I was having a stroke.
No worries. My man said the Laddie and the Lonnie and the Grady are all in the Prezi, but what about the kinematics and the dynamies, bro dog?
No boy, it's just too much. It's just too much. Earthly Skeptic for $2. Alan, what journal are you sending the Celestial Theodolite paper to?
All of them.
Excellent. Let's see. Flatus Earth for $4.99. Clarification: not how the radius was reached. How does the dome height of 6,371 kilometers prevent low Earth orbit? NASA lying? ? Satellites ? I guess I guess what's being said here is that if there is a dome and it's that high, how do we have satellites that are like farther away? I guess.
Yeah, so it's not physical, it's a conceptual model calculation. That's not the actual altitude of the star like in three-dimensional space. It's just used for the purposes of describing the, for linearizing the 60 nautical miles per degree rate. So.
All right, and Earth is Life for $5. Thank you very much. Alan, what is the physical location of the star if it's not actually below your feet 6 hours after it's been occluded?
Just further away from you.
All right, understood. Beasticles, again, for $4.99. Please show one example in Alan's spreadsheet and show how the globe is strawmanned and explain why the refraction amount is that amount. So what I'm going to do is I'm going to copy and paste that entire question internally so you can read it yourself.
So once again, the refraction amount is based, in my case, on actual weather balloon data, ray tracing through that atmosphere based on what was empirically measured the night of the observation, both as I made it and I also looked up the historical weather balloon data for the observations that Alan made and Heffron and whoever else from the data I had available that was made available to me. That data is all available on the GitHub, including the spreadsheets of the weather balloon data. So that is how I am calculating for refraction. Now, Alan keeps talking about geometric intersections, and he's talking about refraction recovering the flat Earth angle. But he's not talking about, he's strawmanning the globe, acting like the geometric intersection is what matters, and it's not. It's about the apparent angle of the target matching the apparent angle of the star. And when you get into targets, in this case airplanes, that are very high and very far, farther than the mountains in many of these cases, higher than the mountains in any of these cases, you end up seeing that the celestial theodolite breaks down. It doesn't match the globe. And so he's dishonest when he says that we recover the flat Earth angle. The flat Earth angle is wrong. It doesn't match what we see in reality.
All right, and let's see. Alan, do you have a response to that? I don't want to just skip ahead.
Yeah, if you can go to my spreadsheet real quick, if you can bring this up.
Yep, hang on 1 second. All right, it's up.
So to make the optical angle work for the globe when the star relative to the observer is at 206, how much refraction is needed to lift it up to the angle of 217, which is what the globe geometrically predicts as the angle to the peak from the observer?
Astronomy Live,
is that a question for me? Well, the difference is about 11 arc minutes.
Correct. Now, Stellarium and Settleman and Gigi Bennett, who are the premier refraction formula specialists for at angles, sub 10 degrees, give values of refraction of 13 arc minutes, 12 arc minutes, and 55 arc seconds, which we can basically call 13 at that point. And then Stellarium reports 13 arc minutes for refraction. What was the value that you got with weather balloon data?
So the value I got with weather balloon data, this was for the first Pikes Peak observation at 1 month, or let's see, in terms of universal time, I don't know if you have it in GMT time, 1 hour, 43 minutes, 7 seconds.
No. What was the star name?
Well, in my case, it's all related to the Hipparchus catalog, so it's HIP 109624.
Oh shoot, yeah, I've got 39 Aquarii. I like the actual names labeled, so I'm not sure. What's the date for it though? We could do date and time.
Well, the date again is in Universal Time, and it's shortly after midnight Universal Time. Its date is January 28th, 1 hour 43 minutes 7 seconds.
28th. I think I only have 27, 31. I don't have that one specifically, but what value did you get?
So the star refraction I get is 0.222143 degrees. The target refraction I get to the mountain peak is 0.028811.
What was the astronomical refraction in arc minutes, if you don't mind? Or you just tell me again and I'll...
I don't have it in arc minutes. I have it in degrees. I'd have to do the conversion.
I got you. What was the DDs real quick? I'll convert it.
Here, I'll post it in the chat. And keep in mind that I am calculating for precession, nutation, aberration, all that good stuff myself. I'm not relying on Stellarium. I'm getting the values directly from the Hipparchus catalog.
Let's see. So yeah, you came up with 13 arc minutes of refraction as well. So literally the same amount. So if you add 13 arc minutes of refraction at the time that the occlusion occurred, you would be 2 arc minutes and 53 arc seconds above the peak for the apparent position with respect to the geometric.
Then why is it that with my calculation, my error is less than 1 arc minute?
Couldn't tell you. Are you using the refracted position of the peak? Because if you do that, then you'll get a 7 arc second difference between the two. If you use the...
Well, of course, I'm using the refractive altitude of the peak.
Okay, well, a refracted image is not where light rays converge. It's not where the physical object is, so it doesn't actually cause an occlusion.
Wrong, and I showed that with the water tank.
So 1 second, I disregard that premise. And then number 2, we can go to different mountain peaks where that's not consistent. So for this one, if you add an additional correction, you can get it to optically match. That's 3 corrections for that. Now, if you go to other mountain peaks, that relationship doesn't hold anymore. Like for example, for North Peak, right? You predict that you would still be geometrically above the peak by 2 arc minutes.
So I don't know why you've changed peaks suddenly, but again,
because the method of which you're trying to analyze from isn't consistent across the whole data set.
No, my method is completely consistent across the data set. Yes, you'll find some where the celestial theodolite angle wins, although even at North Peak, looks like the globe still wins there, but those observations were more off than Pikes Peak for both models. But the Pikes Peak observation you were just talking about, I get an error of the globe less than 1 arc minute. Okay, for that 39 Aquarii, I get a globe error. Again, if I convert degrees to arc minutes, I get less than 1 arc minute error.
Yeah, that's adding 2 additional corrections to make the timing differences match what the flat Earth predicts geometrically. So
again,
well, hold on a second, dog. You went through this whole spiel about how we're not accounting for refraction, but you had a different value because you're using balloons. You ended up with the same values that I did, and when you add refraction into it, that's an additional correction. So you have 1 correction for globe drop that deviates from the plane. You have 1 correction for astronomical refraction to add it in. You have another correction for terrestrial refraction. All that's doing is just making it geometrically flat.
No, what that's doing is making it correct. I mean, that's the actual globe prediction. You want to straw man the globe, you can go ahead and start omitting what you call corrections, but are just part of the math of calculating what the globe predicts. If you want to straw man the globe and keep doing that, go ahead.
It's not a straw man of the globe. I acknowledge the correction, but I'm telling you that in applying it, it flattens out the arc length. The drop over distance exactly gets canceled out. There's 13 arc minutes of drop. You calculated 13 arc minutes of refraction. That should be there.
All right, I'm going to butt in right here so that we can proceed. From Jesse for $5 says, if Alan accepts that refraction would delay the occlusion, then he admits to strawmanning the globe. Did he understand delay of the stars in fish tank? ? Alan,
Perfectly. And that's why you have to take the amount that was measured and then just say it was 11 instead of 13.
Astronomy Live?
Use off, but you want the 217.
Well, I'm telling you what I'm actually getting for the error, okay? Based on calculating it myself from the Hipparchus catalog, you end up with a globe prediction that is less than 1 arc minute. And in fact, in terms of timing error, on that first Pikes Peak observation, we're at 2.5 seconds on the globe. I'm getting 13.235 for celestial theodolite.
Okay, like I said, that's not consistent across all measurements. And for example here, Lucky Peak doesn't share that relationship. The globe predicts 610 for the time of emergence, 611 for flat Earth. And what happens is the apparent position for the star at 6:7 would be below the peak by almost 3 arc minutes. So it should take 17 or 16 more seconds for that star to emerge over this peak, but that didn't happen.
So if you want to share my screen again.
So you're saying that you're going to need more refraction to compensate to just recover the flat Earth angle.
The amount of refraction is going to depend on the conditions at the time, the altitude of the observer, the elevation over the horizon of the peak and the star, etc. You got to calculate it correctly, okay? And when I've done that myself, from the Hipparcos catalog directly, what I see is this. This is the error across the data set. And yes, for the Pikes Peak observation, I get a lower error for the globe than for the celestial theodolite. Across the data set, the error for the globe has a root mean square that is significantly lower than flat Earth. And I do mean statistically significantly at a p-value of less than 0.001. The celestial theodolite root mean square error is 6 times that of the globe.
To optically recover that and get that baseline, you have to agree with our angle geometrically. That's a fact.
Does that look like an agreement to you?
Looks like you did a completely different thing and compared the globe to itself instead of comparing geometric intersections or even the refracted position with respect to GFT. Yeah.
All right. I'm gonna give Alan the last word here before we read the last super chat.
Okay. Yeah. So 13 is not the same number as 11. It doesn't take a super genius to see the difference between that. You're exactly compensating for the amount needed, which entirely recovers the flat Earth angle every single time. That's what every one of those graphs I shows.
And for £5, this isn't the last question, just the last super chat.
Can we burn through these kind of quick? I got to dip.
Yeah, absolutely. I'll be very, very quick. Deplorable Ilk says, Alan denies using optical measurements. So how did he see the occlusion? ? Answer that, and it's 2 more.
We're comparing timing intervals to what the optical measurement would predict. And we can do a geometric analysis based on true positions at that time of occlusion to differentiate between optics and Euclidean geometry.
All right, and this is a question from AT2 Productions. It says, given that it's a gorgeous cloudless, albeit cold, clear night tonight, why are we wasting our collective time with idiots who refuse to accept reality when it stares them in the face? I will answer that because it's fucking cold outside and I don't feel like freezing my ass off. So there's that answer. The second one, which I believe is more relevant to this, Alan, do you agree that weather balloons transmit back accurate data?
Sure.
All right.
I don't see any reason to doubt it off the cuff.
All right. And Astronomy Live, do you agree that weather balloons transmit back accurate data?
Yes, I do.
Excellent. Okay, cool. So with that, Astronomy Live, I'm going to give you a moment to say your last word. And then, Alan, I promise you that you would get the last word overall. This is me meeting that promise. So Astronomy Live, last word, closer, say what you got to say.
Yeah, so I feel like nothing's really going to change here with Alan's take on things, and I wasn't expecting that, but I hope I've demonstrated to people sitting on the fence that the flat Earth and the celestial theodolite do not match reality as well as the globe by a country mile. I've done these observations myself now and recapitulated the radius of the Earth, and when I look at the flat Earth versus the globe error, I see that the globe consistently fits better than the flat Earth. And when I look at Alan's data set, I see the same thing across the data set to statistical significance that is extremely, extremely high, and with an RMS that is 6 times higher for flat Earth. All of this tells me that the Earth's not flat. Big surprise, right? Well, again, this is based on his method of doing things with the airplanes, and then I went and verified this by picking a target even higher, even further away, a balloon, a weather balloon, and directly measuring the angle to that weather balloon. And what do I see? I see that it, again, matches the globe, and it does not match the flat Earth at all. If flat Earth were true, I wouldn't have even been able to find the balloon. It would have been several times the vertical width of the field of view outside of the field of view. You want to talk about being outside the field of view? It would have been outside the field of view if Earth were flat, and I would have never found it because it was far too dim to see with any kind of finder camera or even the refractor riding piggyback. The only thing I could see it with barely was the main telescope, which has an incredibly narrow field of view. We're talking 20 by about 11 arc minutes here. So the vertical field of view of that widescreen video is only about 11 arc minutes. Okay, that is basically tiny. It's like looking through a straw. Okay, the moon and the sun in the sky are about half a degree, right, or about 30 arc minutes. So imagine 1/3 of that. That is the breadth of the field of view of my telescope in that situation, and you're dealing with something that is incredibly far away, incredibly hard to see. If it's not in the field of view, it's like finding a needle in a haystack. You'll never find it. And this isn't the first time I've done something like this, where I've needed reality to end up matching the globe. I've needed to account for refraction. I've needed to account for the drop of the Earth. The shirt I'm wearing is Starship Flight 4. This was the first time that I saw an intact starship from Florida in broad daylight. And I tracked it, again, open loop tracking, meaning not based on seeing something in a finder camera, but rather based on finding it directly, based on what the globe expected, based on where the globe said it would be. And doing that, I was able to correctly track it and find it popping out of the blue sky during engine shutdown. It's not even visible before then. And then when the engine shutdown happens, suddenly it's right there in frame. Did that, again, from the same spot we filmed that balloon from, the Sunshine Skyway Bridge in Tampa, thanks to the fact that the Earth is a globe, and reality ended up matching that. So I was able to track that open loop based on the trajectory of Starship launching from Texas minutes before I saw it flying south of Florida. If Earth were flat and it was trying to get up there somewhere, it would be at the wrong angle, just like this balloon would have been at the wrong angle if Earth were flat. Yes, I've accounted for refraction in these observations, but when you start to look at things that are 6 degrees above horizon, refraction starts to reduce. And with a balloon this far away, the delta between the flat Earth and the globe is far higher than refraction. Refraction doesn't explain it. Even if you looked at just the geometric angle and pretended refraction wasn't a thing, you would still see that the globe would win by a huge margin. So with all that said, I don't think that Alan's going to change his mind. I didn't expect that going into this, but I do hope that people around on the fence who aren't in that rabbit hole can see the reality that is at play here.
All right. And Alan, you have the final word, and we will conclude after that.
Okay. So throughout the debate, geometric analysis of stars occluded by mountain peaks was avoided, and the implication of adding the drop-over distance back in as a refraction correction was ignored and said that that's, stated that that's part of the globe. Well, if you were correcting optically for the geometric difference between flat Earth and globe, and it just so happens to be that you're correcting the baseline such that it's flat Earth every time, then that's not, you're not proving anything. We can make the prediction based off of just using rise over run to the peak, and when we add the arc length back, we should be off by the elevation difference that we failed to account for. I showed that several times in the spreadsheet. That's never the case. I also showed the how the intersection differences because of the stars lingering affects the air in the measurement, and how that relates to the central angle as per Euclid's theorems on tangent and chord theorem, central angle theorem, and inscribed angle theorem. To do the complete geometric analysis of that, you have to understand those theorems. They're pretty straightforward though, and then when you get into comparing what the globe geometrically predicts for its baseline to have the deviation for refraction to explain the deviation from that, you'll see that the Earth curvature, when we do a Gaussian distribution on the occlusion angle versus the predicted angle for rise over run versus the observer-centric position of the star with the rise minus globe drop over run, we see that the globe is outside of the Gaussian distribution pretty much every single time, and flat Earth is within spec. Like using just trying to compare the globe to itself with optical angles isn't going to yield a different result. A large portion of the analysis offered tonight was circular, and I look forward to going through the new data and getting back to him on this. So I'll see you guys on the return. If anyone has any questions about the celestial theodolite, the method, or wants to contribute to data, etc., or participate, all the information can be found in the Discord, and the link that Red's put for the presentation, where all the resources are here and available as well.
Yep, and to both of you, before we end, I need both of you to send me all the relevant links so I could put it in the description so that everyone can find it. So, ladies and gentlemen, if you would like to find any of these details, again, it's in the description down below. I would like to thank both of you for not turning this into a cataclysmic shit show. That is very, very nice, and I would very much like to set this up again a month from now or a month and a half from now, however long it takes to go over what Astronomy Live presented, so we can do this again. In the meantime, guys, thank you very much for watching. This has been great and fun, and with that, we are out. Peace out. Bye-bye.
All right, before I dip, can you...
The heck, bro? They just had 4 men dancing to a girl song, bro. That was great.
But dude, it was Dolby Surround. What the fuck are you talking about? That was sick.
I'm sorry. Do you think that dancing is gay?
Super gay.
I can't hear you, bro.
So gay.
Do you
So
think
gay.
that
You can't
dancing
even
is
hear you.
gay,
It's
or
that
what?
gay.
Like, what do you have against dancing? I'll dance you off anytime, bro.
Yeah, you don't want to dance off. Max,
Holy
trust.
cow, dude, get a grip.
I have the sun.
Astronomy Live, I think
on
you're
here.
away for a second.
Yeah. Oh, yes.
You're
I
asking
asked that
about
question.
your how you were able to
predicted
calculate.
an eclipse for, I think, the year 3001, right?
Yeah.
Did you use the solar cycle?
No. No, and that certainly wouldn't have told me the path it took. No, I used my spreadsheet that I developed. Well, Lord, I did the moon side of that spreadsheet 13 years ago and posted it on my channel, and then did the sun side some years later, where I worked in. When I did the initial version of the spreadsheet, it was primarily for calculating the position and orientation of the moon to refute the claim that Cheshire sideways moon is unusual, which is coming back around again. I don't know if you guys have noticed that. It's coming around again on Twitter. I debunked that 13 years ago using this spreadsheet, right? Well, for that, I needed to know where the sun was. I used a very simple formula for that. It wasn't terribly accurate past, a few years. And so I came back, I was like, okay, I did really good on the moon, but I really want more accuracy on the sun. So I then came back to it a couple years later and updated it again with more accuracy using equations based on Simon Newcomb from the 19th century to get it much more accurate. We're talking, basically an arc-second accuracy and for the position of the sun. And so then when the 2017 eclipse happened, the first great American eclipse that went from, the northwest down to the southeast through the continental United States, I went up to Casper, Wyoming to film that. And I had it set for myself that before I got there and before I filmed that, by golly, I was going to work out how to predict the path of the eclipse myself without anyone telling me, like, how do you do this? I just knew I had the spreadsheet. It accurately tells me where the moon is. It accurately tells me where the sun is. I know the shape of the Earth isn't flat. So let me figure out, like, how do I predict this? And I worked it out. I worked out the math on how to predict the path of totality. Is one of the things I'm actually most proud of, and honestly, that I've done in amateur astronomy. So in 2017, I worked that out. And then 2024, eclipse rolls around 7 years later. I go up to Maine and film it again, run the prediction again. This spreadsheet runs, like I said, on the orbit of the moon and the sun, the Earth going around the sun to determine the position of the sun. And from that, I figure where the moon's shadow is going to land on Earth's surface. Okay. So for that, you have to look at where that's projecting onto the globe's curved surface. So basically, to predict the eclipse in 3001, well, first of all, I knew the 5 millennium canon of eclipses ends in the year 3000, right? So I know that at some point thereafter, there's going to be another total eclipse. So I did it's very dumb, but this is what I did. I sat there with a spreadsheet, and I went day by day looking for new moons until I found one that actually was a total eclipse. And I found it in October 3001. And then I worked out from the time, just going minute by minute, oh, here's what the path is. Easy. And it's not based on Saros cycle or anything else. It's based on the actual orbit of the Earth and moon.
Can you hear me now?
Yeah.
Oh, finally. Sorry. Yeah, so what I wanted to say earlier about the Saros cycles and the eclipse predictions, right, was that those models that are like modeling the eclipses, they're actually being updated in real time as it gets closer and closer to the date of the eclipse. And they're taking, because there are perturbations that are not able to be accounted for
Gravitational
beforehand.
perturbations.
Yeah, whatever the sources are. Yeah, sure. Yeah.
So,
but
can I make a point?
All right.
Can I jump in here? The gravitational perturbations are pretty well accounted for. What they updated most recently was more to do with the exact size of the sun, the size of the photosphere, which is empirically derived, of course. But that said, I went and observed the 2024 eclipse from where my spreadsheet said I should stand based on orbital elements I've had in there for about 13 years now. It didn't need updating. It worked. I stood where it told me to stand. I saw totality. I dare you to find me a flat Earth model that can do that. That can tell me where to stand to see totality.
Yeah, so that was I was trying to get there, man. The point I'm trying to make, right, is that there is not a purely dynamical model that does not take into account previous eclipse data that can predict future eclipses way out into the future.
Wrong.
with sub.
So what's a dynamical model?
I'm
I've
not
never heard of
finished.
that.
With sub 0.1% accuracy, which would be like a minute or two that you're talking about.
Dude, you can't even.
I literally did it.
You just said it was from 14 years before. That's for 14 years out.
Yeah, and
so it's based on the orbit of the Earth and Moon.
So what's 10% of 14 years?
I said a tenth of a percent.
He only has to get the prediction right within 1.4 years in order to match your status. But returning back to what you're saying about Saros cycles, it's complete because Saros cycles start and they stop. When you see a partial eclipse, this is a Saros cycle starting or ending, because they don't go on forever. And they don't, and they haven't been going on forever. Yes, once you've got an initial eclipse, once you've got an initial partial that starts the cycle, then you can calculate the rest of them using Saros cycles. But Saros cycles start and end. So predicting every eclipse cannot be done just by looking at Saros cycles. That is a pig ignorant. You clearly don't understand what Saros cycles are if you're even going to propose that as a mechanism for predicting eclipses.
Yeah, the whole point, I think that the whole point that you might not have understood what my point was, is there's not a mutual exclusivity to globular orbital dynamics in order to
predict the sunset.
Why do you interrupt me before I can finish
my
point,
channel,
man?
my house, bitch.
I mean, I'm being
this
very
gets back to the question
very
that I
kind
was
and
asking Astronomy Live that he was gracious enough to respond to. and sorry, I should have come on in person to ask it, but if you can't predict that, flat Earth cannot provide an accurate model for star paths, right? It does not provide such a model. And the Bislin model, Astronomy Live, please confirm if I'm correct on this, but it would give stellar elevations that are extremely different for observers at high altitude. So if you hopped into a plane, and we know that pilots in the early 20th century were able to use celestial navigation, without making the ridiculous adjustments that would be necessary under the Bislin model. So we can tell that the Bislin model is not accurate to reality. So we're back to the case that flat Earth cannot even tell us first order features about the behaviors of celestial objects. And now you're claiming that the ability to predict eclipses is not exclusive. Yes, the ability to predict the start of a Saros cycle is exclusive to a globe Earth looking at the dynamics of the Earth Sun or the Earth Sun Moon system. That is exclusive to.
What do you mean it can't be predicted? You can literally use the periodicity of them as they repeat in cycles across time.
At the start of a Saros cycle, there is no previous event from which to calculate the cycle. That's what the start of the cycle means. There is no previous eclipse from which to project a future event. Some, not all eclipses, but some eclipses occur at the starts and ends of Saros cycles, right? Do you understand that is the case?
Yeah, you're talking about the slight imprecision or irregularity in the eclipses within the bands of one particular cycle.
Nope. Saros cycles start, right? So a Saros cycle says there will be an eclipse every, however many years. I can't remember the exact number off the top of my head, but these cycles start, they go on for a long time, and then they end, right? You cannot predict when these things will start using a flat Earth formulation because you've got no previous event from which to say this will occur, however many years later.
That's exactly how Fred Espenak built his, data charts out hundreds of years backwards and forwards.
Then he's wrong to do so because Saros cycles begin and they end. Are you aware of this?
You know that Fred Espenak is the one that plots all of NASA's eclipse data for like the past 25 years, right? Or however many years it was.
Well, sorry, please, I may be wrong about this. Astronomy Live, am I correct about Saros cycles beginning and ending?
Yeah, as far as I know. Now, the Saros cycles are relevant to me because, first of all, they don't tell you the path of totality. They tell you timing, and you can work out generally what part of the Earth is going to see the eclipse. But that doesn't tell me where I need to stand to be in the path of totality. That's a narrow window to hit. You got to be right. And to do that, you need to know the actual orbit of the Earth and Moon. The Besselian. So this is why Shane went on and on about Besselian elements. This is why Alan referenced it tonight, is because they were trying to claim that that is a flat Earth method for predicting eclipses because it involves a flat plane. They did a quote mine. They found the word plane. They were like, oh, boom, that's it. That's the flat Earth method that predicts eclipses. No, what that is the fundamental plane bisects the globe. I have a book. I guess I should look for it. It's somewhere here in my collection. I have a book that, first of all, I've got a book that Espenak wrote himself. I've got his book. He's passed away now. Rest in peace. He was an expert on eclipse prediction, and he listed the eclipses by Saros cycle, but he's predicting them not based on Saros cycle, but based on VSOP and based on ELP 2000. He's basing them on the orbit of the Earth and Moon. That's how he's generating the path of totality. Okay, I'm using Simon Newcomb's equations for the orbit of the Earth that go back from before 1900. Okay, we're talking 19th century data here, but it was so accurate that they used it until the 1980s. Okay, so you can use that to still predict eclipses out 3000, to 3001, like I did. And I challenged Shane to do the same. For this, he blocked me on Twitter and hid my reply when I challenged him to predict the next eclipse after the end of the sequence. If it's really just a sequence based on Saros cycles and you can just predict it forever, why couldn't he predict the path of totality for October 3001?
I guess because he couldn't find the data. Let me read a couple more messages. Jack Fetter for 189. Boys have penises, girls have vaginas. I mean, thank you. I didn't know. That was valuable information. Deplorable for £5. Astronomy Live didn't answer the big question. Did planes dip their nose?
Oh, I did a whole thing on that.
I got 2 videos on that on my channel. Go check it out.
Astronomy Live, look at my video. Watch my video. Tell me I'm wrong.
Okay, I'll have to go watch your video.
So Sorry.
One more bit, just a quick joke. Hakraba for $2 says Polaris is near your big toe. It is. It's actually that way, which is kind of weird if the Earth is flat, if you ask me. Let me welcome Eric, and Tony wanted to say something. I need to go to the toilet. I'll be right back.
Oh,
Eric's job
the
is
next new solar cycle is going to the next new solar cycle is going to start in 2040, right? So solar cycle 158, sorry, is going to start on July the 3rd, 2040. That is going to be an eclipse for which there is no previous eclipse. The last few to begin, I'm looking this up, obviously. Saurus 155 began in 1928, 156 began in 1946, Saurus 157 began in 1964. So Saurus cycles begin and end all the time. Once they've started, yes, every 19 years or so, you get another eclipse. But as Astronomy Live so eloquently explained, that doesn't give you the path of totality nor any of the details about it. You cannot predict using a flat Earth formulation when a new solar cycle will begin, nor when a solar cycle will end.
Yeah, here's the thing for solar cycles, like because of the fact that it doesn't give you the path of totality, like for either a lunar or a solar eclipse. Like I honestly have never seen anything about a solar cycle, even in a textbook. Like I have a degree in astronomy, and I have never seen anything about solar cycles, even in a textbook.
Yeah, I mean, I literally ran the prediction myself using my own spreadsheet. I never once used a Saros cycle, ever.
Yeah.
It's not based on that. It's based on the orbit of the Earth and the Moon. That's how you have to have that to get the path of totality.
Look, if you're deriving your own equations, Astronomy Live, you're just showing off.
I mean, I am, but okay, I guess a little bit, yes. But to me, it's fun. It's like this little puzzle, and you work it out, and then you get the answer, and it matches reality. It's like, oh, I get the dopamine hit from that,
See, if I was teaching college astronomy, I'd have my students derive the path of totality. But I'm teaching high school. My students are not that equipped for the math for that.
Yeah, I have to say, Astronomy Live, I admire your dedication, the amount of effort you put in. Like my argument would be, until they can explain why stellar paths are circular, I'm not interested. Like I'm not prepared to entertain any of these conversations in good faith at all. This quibbling over occlusions doesn't interest me. Give me a model that can explain why star paths are circular. And I've asked Alan for that, and he's just refused to sort of engage with me anymore. For reasons I think I can understand, but he will obviously dispute.
Hold on, who's not engaging with you anymore?
Alan from Space Audits.
Oh, okay.
So,
Beast.
Oh, sorry.
Is Beasticle still here?
No, he had.
Oh, he left.
Oh. I found those links and I pasted them in the side chat, and I also found. So this is just I'll read a little short clip excerpt about the delta T on the Saros cycles in the Saros cycle series, and in the eclipses within them. It says that the largest uncertainty in the eclipse predictions is caused by fluctuations in Earth rotation, due primarily to tidal friction of the Moon. The resultant drift is apparent clock time expressed as delta T. Before the 1950s, delta T was calculated by empirically fitting historical records derived from Morrison and Stefferon. From the 1955 till present era, delta T is obtained from published observations. And for the future, delta T is extrapolated from current values weighted by the long-term trend from tidal effects. So in reality, once again, they cannot precisely predict the timing. They have to update it as they go with observations in order to predict future ones to get the delta T down smaller and smaller. The closer they get to the actual event, the delta T shrinks.
Again, I predicted the 2017 eclipse and the 2024 eclipse, and I went and observed both of them, where my spreadsheet said I should be a spreadsheet that I originally developed in 2013. So
That's
I didn't
not
need
far,
to update.
bro. 13 years is nothing.
13 years is. I'd like to see you do it.
Years is a lot.
I would very much like to see you do it. Piezo,
were you not listening when I was explaining that the next Saros cycle, the next new Saros cycle, will start in 2040, and that is not predictable from previous eclipses. Similarly, the last Saros cycle to ended in 1971. So Saros cycles start. During that time, the eclipses are regular, and then they end. You cannot just say we can predict eclipses from the previous eclipse, because they start and they end. You cannot predict the first one, and if you predict that there will be another one after the Saros cycle has ended, you're wrong. So you can be wrong in both ways. You can fail to predict an eclipse that does occur, and you can predict an eclipse that doesn't occur. So just saying, because of previous entries in a solar cycle, I can predict the next one in a solar cycle.
Yeah.
That does not allow you to predict all eclipses.
So can I go back
Oh,
to
really?
something he
Because
said here?
I have a 1,000-year canon of eclipses right here that I just pasted in the side
Yeah,
chat.
good.
Great. Let me say something. Piezo, the Saros cycles can predict the timing. It can't predict the position of where the eclipse
The path of totality.
Yeah, exactly. It can't predict the path of totality. And one reason why I came on here is because there's a very funny story of when someone had to completely guess onto if the eclipse would be seen from their position for a Saros cycle that they were using for that, where the timing was correct, but they really were not sure if the position was correct. How many of you know the story of Christopher Columbus's 1504 eclipse when for how he got back to Europe?
Oh yeah, I kind of vaguely remember that.
Yeah, so Christopher Columbus in 1504 was almost stranded in the Caribbean for problems that happened with like a ship I think it was in Jamaica, and the locals didn't want to help him. And Columbus knew that a solar cycle was coming up with a lunar eclipse, and he was just like, all right, well, he had to hope that it was going to be, one, a total lunar eclipse, and two, that it was going to be visible from Jamaica. And he was right that it was visible from Jamaica, but if it wasn't, he would have been stuck in Jamaica and would have died there. But it's a solar cycle that ended up being one that he actually could see from his position, because lunar eclipses, you have a 50-50 shot if it's visible from your location.
Can I ask Piezo a question?
Yeah.
Oh, great. Even before Haversign. So Piezo, you pasted that list of solar eclipses, right, in the chat. How was that derived?
So I just gave the link that stuff comes from, or a lot of that stuff.
How was it calculated?
Yeah, it comes from Fred Espenak, who uses a combination of Saros cycles along with Magellan elements.
I see. I'm looking at the 2017 August eclipse. So that would be a solar eclipse, right? That is on the list?
If it's on there, I mean, I don't know every eclipse that's on there.
Okay, so it says
Can't confirm because I saw that eclipse.
It says 2017 August 7th. There should be a solar eclipse. I saw that eclipse. It was on August 17th. It is off by 10 fucking days. Your list that you pasted that was derived based on some flat earth math or based on whoever you said is off by 10 days.
My NASA.gov list is off by 10 days.
The list you pasted, the 1,000-year canon of lunar eclipses. I see. So that was a lunar eclipse.
Yeah. I think you're getting lunar confused. The solar eclipse, right? The path of totality. You mentioned delta T. You mentioned tidal forces, which is because of gravity of the moon, and as tidal forces are exerted by the moon on the Earth and the sun, for that matter, it slows the Earth's rotation, which gives us delta T. Right? That's all dynamical, right? So yeah, we can extrapolate what that's probably going to do in the future. The thing is, we can do it with such accuracy that I can create a spreadsheet in 2013 that works for predicting a total solar eclipse in 2024. And the moon, the tables of the moon that I used were published in the 1990s. The tables of the sun I used were published in the 19th century. Okay. Yeah, I created the spreadsheet in 2013, but I don't think you understand how impressive it is that based on an orbital elements of the sun that were calculated by a guy who's been dead for longer than NASA's been around, that I was able to predict where I needed to stand to see the 2024 eclipse. I'd like to see you do that with a flat Earth model. No one can.
I don't know. You should. I don't know. You should probably check with Shane and Mordwand on the $10,000 bet he raked in. I mean, I personally saw him get paid out on it. So
Shane has blocked me and hid my reply when I challenged him to predict the eclipse in October 3001. He does not want to talk to me about that at all.
How are you guys ever going to verify it's accurate? It's 1,000 years from now. We're all going to be dead.
He couldn't even produce
on the board one claim in the back chat.
Well, can't
Are
we,
you aware
can't
that
we, can't we use the 2040 eclipse? So there is a new solar cycle. This will be an eclipse for which there is no previously existing solar cycle. It will start in 2040. So this is something that cannot be achieved. This prediction cannot have been achieved using solar cycles because there's no previous eclipse in that cycle.
So
can that not be used to prove that to prove you wrong? Cannot the fact that previous solar cycles have started 1928, 1965, for instance, new solar cycle started. These are new series of eclipses that were not previous. So can we not use those to disprove your claim that every eclipse is predictable using solar cycles?
So I will say this. If you remember last year, there was a solar eclipse that swept across the southeastern United States. And the day before, like the week before that, they had, listed a path and a time. And if you will remember, the day of, they updated the path ever so slightly because of the live data as it comes in of watching the path of the sun and the moon leading up into the eclipse. They had to make a small, I don't know what the percentage correction was, 1 or 2% correction that they had to make. But the point I'm making.
I guarantee it wasn't
1 or 2% of what?
I guess
What
it
are you
was a
saying is
10-day
the justice?
difference.
What my point is that if you want to talk about predicting future eclipses, you're saying that there's no way you can predict the path unless you use what? That's mutually exclusive to a globe.
The globe.
The globe and
Specifically,
the
what
Earth
do you
and
do?
the moon's
Step by
relative
step, tell me.
positions and their relative position and their positions relative to the sun. So the positions of each of these objects through time, the relative positions of each of these objects through time is what is used to predict to predict eclipses. For that to work, you need a sun that is approximately 96 million kilometers away. Sorry, 140 million, 96 million miles, 140 million kilometers. And you need a sun that is, 320,000, something like that, kilometers away. It's incompatible with, those are the inputs. You'll have to forgive me, Astronomy Live. I'm sure I got those numbers.
I'm trying to keep my mouth shut there. Sorry.
I'm with you there, Astronomy Live.
I will. I want to dial it back just as coach, and let me remove this. So why don't we go back a little bit more to the basics? This is the prediction for what will happen on March the 20th. I will be in Montevideo, Uruguay, looking west, and the sun will go from my right to my left. Icy spin is going to be in Tallahassee, Florida, also looking west at the same time. And for him, the sun will go from his left to his right. It's plain.
That's right. What's the flat Earth prediction for that?
What say thee?
The silence of concession?
Well, here's an easy one for
Yeah,
Pietro.
Pietro, what's your prediction for why one of them sees it left to right and the other one sees it right to left?
And why both of them see it setting.
I'm sorry, I wasn't listening. I was reading some stuff. What was the question, man?
So March 20th, I will be in Montevideo, Uruguay, in the coast, looking west at the sunset, and it will go right to left for me in my looking west, right to left. And Icy Spin will be in Tallahassee, Florida, also looking west at the same time. And for him, the sun will go left to right. Explain.
You're talking about in the northern hemisphere versus the southern hemisphere?
That's right. Yep.
So the sun is in between you two, and he's looking south towards it, and you're looking north towards it?
No. Looking west. We're both looking west. We're looking at the sunset.
Okay.
I can show you how it works.
I have an easy question for Pietro.
No. Stop.
No, we're just gonna let him.
Let's stay on one topic at a
No,
time.
he's not going to run away from this. We're both looking west at the same time, and we're seeing the same thing move opposite ways. How does that work on a flat Earth? Because on the globe, it's very easy. I'm upside down relative to Icy Spin. That fixes
To clarify, Max, this is going to happen within less than a month from now, right?
Yeah, March the 20th.
Very
we're
soon.
going to
Okay.
live stream it for everyone
3
to
weeks
see.
away.
Literally 20 days away.
Yep.
I can explain it on the globe. Piezo, go ahead.
Are you asking about, look, just to clarify, are you asking me how the sun, as it goes west and sets, appears to go clockwise or counterclockwise?
No. It's a fairly.
Right.
Can I repeat the question that I thought I heard to see whether or not Piezo is actually paying attention? One of you is in Tallahassee. The other one is in Montevideo. You are both going to be observing the sun setting in the west on the evening of the equinox.
Yep.
You have longitudes that are approximately equal. One of you will be seeing the sun go from left to right as it sets, and the other one will be seeing it go from right to left as it sets.
Yep, exactly.
Keep in mind that left to right is not east or west. East or west is east or west. Left and right is different.
Yeah, we are both looking to the west, the place where the sun sets. So right and left become absolute.
Yeah, that's why I said clockwise and counterclockwise.
No, it's got nothing to do with clockwise or anti-clockwise.
Well, if I'm looking at these pictures on the screen and I was looking from a top-down view, that yellow line on the left looks like it's moving counterclockwise, and on the right it looks like it's moving clockwise.
They're not looking at it top down.
I know.
No,
but
they're on the ground looking west.
I'm on the red circle.
I know, but okay. Yeah, I was trying to talk about the picture on the screen in a way that left and right are like relative, so that's
No,
why
they're
I was.
not. That's why I told you we're looking west. It would be like we're both looking at a wall. So we're both looking at a wall, but I'm upside down. So right and left get crossed. But we're both looking in the same direction, the place where the sun sets, which is west.
Right, which would be a circle on a disk. Or a circle around an equator on a ball. This is the spring equinox, right? So it's tracing a circle around the equator. So in either case, if you're on a ball, you would have a person slightly north of it looking west, and they would see it, curving up and to the right a little bit. And then on a person on the bottom side of a ball, they would see it tracing the equator west, which relative to them would appear like it's slightly curves to the left a little bit. Is that what you're saying?
Yeah.
You're saying on an FE, you would expect a person in the north to see a curve from left to right, and then a person in the south you would expect them to see it continue curving to the right instead of to the left. Is that what you're saying?
Yeah.
Yeah.
I mean, it shows it very clearly here. It will go from my right to my left, and it will go from his left to his right. That's impossible on a flat Earth.
Well, question. I see where Piezo's coming from.
And this happens every day.
I see where Piezo's coming from here, but if the sun was local, do you believe the sun is local?
Well, I think that we're seeing a projection of the sun. I don't think we're physically seeing a ball of fire. I think we're seeing an image.
Oh, God damn it. Okay, so is it local or is it not local?
Well, the projection is local.
Okay, so if they were to both also capture the sunspots on it and verify that they're both looking at the same face of the sun, what would that do for you?
It would go ahead.
So on a flat Earth, I mean, you'd be looking at different areas of the sun, right?
Well, you'd still be seeing a face of the bottom half of the sun, like being projected through the lens above our sky.
This leads to a whole other discussion of like what's projecting the sun, holy moly.
I would say it's probably being projected out the bottom of the firmament. So it would be a collimated
on the
projection.
bottom of the firmament up to the firmament and then
the firmament has like a thickness to it, right? So like I don't know how thick it is, but it's like the sun would be inside of it.
Can I ask? You just used.
I'm a Christian, right? So I just believe what the
You
Bible
just
says
used
about
the
it.
word probably.
Yeah,
you used the word probably. What is the probability you assign to the sun being projected through the firmament? What is the probability you assign to the firmament being real? What is it made of? How big is it? What are its physical characteristics? How does it sustain the strain of stretching over at least 13,000 kilometers?
Yeah, so I overlap a couple different things that make sense together, right? So like first, I begin with an assumption, like my worldview. I assume that there's a firmament. And then I say, if there was one, what would I expect to see?
What is the probability you assign to the existence of the firmament? And what is the probability you assign to the existence of the firmament?
Well, based on my worldview, 100%. So
there's no chance you're wrong.
I'm not saying there's no chance I can't be wrong. I'm saying that based on my worldview, I believe it to be true. So
where in the Bible does it say the sun's a projection?
If there's a hold on, if there's a firmament, which I'm assuming that's my starting point, and I say, okay, what would I expect? I would expect that if it's a lens, right, then it would collimate the light coming through it. So what we would see was a collimated projection. Now, if you know anything about collimated projections, you know that they maintain the same angular size regardless of the distance of the light source. So I would expect to see a sun with a consistent angular size as it moves across the plane. That's exactly what we see. So it would be consistent with that.
Stacking assumptions with no supporting evidence for any of them.
It's just convenience. It's convenience. So where in the Bible does it say the sun is a projection?
It says in the Bible that there's a firmament and that the sun is inside of it.
Okay, so where does it say it's a projection?
But you said it was projected through the firmament. So is it inside or outside projected through?
It's inside, and we're under it. So the light coming through it would come out the bottom and would be collimated by the lens of the material of whatever.
No, it can only come out through the collimated lens if it's above the lens. It can't come through a lens that is below.
That's fine. There could be layers to it. I don't know exactly how it all works. It's made to be unknowable.
It's 2026. I do not know how it all works. I don't understand.
Dirt has been patiently waiting and has a question.
Oh yeah, Dirt, what's up?
For it.
Yeah.
Sorry,
Piezo, is that how you say your name? I have a question for you. Piezo?
Piezo.
Okay. Piezo. Okay. Sorry. I apologize. I probably am going to pronounce your name wrong. So, okay, your whole thing is you're talking about the left to right, the right to left for the sun. So you probably do the same dumb shit that I've seen Witsit do with the clock on the roof and standing on different sides, everything like that. So if you have the number 9 and the 9 is facing north and you're standing at 9, if you're standing at north, it's going to look like a 9. If you're standing at south, it's going to look like a 6. But if you're standing at east and west, what does that look like?
I mean, they'd be flipped over relative to each other, be opposite.
In every direction, it would look like something different. Is that how we see it on Earth?
Like the orientation of the 9 and the 6 are 180 degrees from each other, and if you rotate them 90 degrees to be east to west, they would still be 180 from one another.
But that's not how it would work. If it was in a central location and you're looking from east or west, you'd be looking at the side of the 9.
Right, that's what I'm saying. It would be rotated 90 degrees.
Okay, but then everybody is looking at it a different direction. Is that how we actually see it on Earth?
Everybody, well, are you talking about looking directly due west at your position versus
So
another
when you're
due
looking
west
at the
their
moon,
position?
it flips from north to southern hemisphere. Does it ever flip right to left for people in the west or the east?
Does it ever flip right? Well, if there's a person with the moon at their zenith, and then there's a person like east or west of that person, and the person east and west of that person will see the moon flipped relative to the person in the middle.
No, they won't.
What?
No, they won't.
No.
Oh, boy.
Okay. So the only way the moon orientation flips is from north to south, and it flips 180. There's no 180 flip from west to east.
There's field rotation, right? But you don't get a change
But yeah,
in perspective. The diurnal. So you get diurnal libration, right? You actually do get some diurnal libration from Earth
Yeah,
rotating
but it's
east
not
to west,
gonna.
but it's tiny. I can show you. I have a time lapse of it. It's tiny, but
Yeah,
I was able to use it to actually make a 3D picture of the moon. As
The
amount
No, yeah, I completely agree. I've had to adjust for it.
The amount of libration that we get over a full lunar phase cycle makes it so we can see 59% of the moon over a full month.
Right, and even over a few hours, there's a little bit there from Earth's rotation, but it's even smaller than that. It's not even 59%. It's like, tiny amount.
Yeah,
it's just enough.
I've had to adjust for a 12-hour time lapse in my.
I gotta ask you a question real quick, Dirt. So I'm assuming a globe model right now in my head. Okay, I'm gonna assume that the moon is directly over the equator at the zenith of some person, like right under it. Okay, now there's a person many degrees due north of that person, many degrees due south, many degrees due east, many degrees due west. Right, so there's 4 people around the central person, so it makes a cross. Okay, so this person in the center of the cross sees the moon at their zenith. You're saying that the people to the north and south of them will see the moon flipped across the horizontal axis, but the people east and west of them will not see the moon flipped across the vertical axis?
Kind of, but no. So, okay,
It wouldn't make any sense.
You
Or why
have a
would there not be
9 on the
symmetry?
roof in a room. So you have a perfectly square room. You have a 9 on the roof. So you have someone standing on one side of the room where the 9 is towards the top of them, and someone on the bottom side of the room where the 9 is to the top of them, like how Max just flipped it. But then you also have someone to the left and the right. So every person in that room is going to see that symbol differently.
Yeah.
That doesn't happen on Earth. That's not a thing that we see.
Well, what I'm saying is if I was to draw 4 arrows all pointing towards that 9, one from below, one from above, one from the left, one from the right, and you were to flip that paper so that the arrow was extending away from you towards the 9, all 4 of them should see 180 degrees flipped across one relative axis, either the horizontal or the vertical axis, depending on if it's east-west or north-south. To say that
So
only
you're
north.
saying there's 100 degrees between
never
west
happens.
and north.
But I think the problem here is the assumption that the moon is local.
Yeah, I mean, yes. I'm absolutely using that assumption, but
And,
that's not.
And I think Piezo's point would instantly that the fact that he's described something that should occur if the moon is local and doesn't occur.
Yeah,
that should suggest to you that the moon isn't local.
Yeah, exactly. That's my point. There's no circumstance that you're going to see the moon in a circumstance where it should behave locally.
Like you don't get this or this ever. It flips this way or this way, whether you're in the north and the south, and that's it.
No, but why would symmetry be broken? Like once again, if we're on a symmetrical sphere, and I use the cross setup that I just explained, and the moon's at the zenith of the center of the cross, if I spherically symmetrically rotate myself around a circle of equal radius outside away from that zenith, whether it's to the north of the zenith, the south of the zenith, the east of the zenith, or the west of the zenith, every person, you're saying that the north and south relative movement will produce a flip, but the east and west won't. Why would that be? That doesn't make sense.
It's the relationship between Earth's axis of rotation and the moon.
Exactly.
And our orientation relative to that axis is what's changing as we move from north to south. But
Which
that
is what
isn't
causes
changing,
the-
but that
the-
isn't changing as we move east or west.
And that's what causes that the sun will go right to left for me and left to right for Icy Spin on March 20th.
No, I get you factoring in Earth rotation, right? But once again, it's still, if we just freeze time, we're not in a time dependent situation. We're at a moment in time in my illustration. It doesn't make sense because who cares if the Earth has an axis that spins? In the illustration, it's not moving; its time is frozen. So it doesn't make sense for me to rotate the sphere 90 degrees because in my illustration, it doesn't matter that the ball has an axis, right? The axis is not relevant; it's a symmetrical sphere. So I could rotate it any amount of degrees, and you wouldn't know the orientation of the axis. You could still draw a cross, and you would think that moving to either of the four quadrants of that cross would produce a rotation of the thing above you. How can only two quadrants produce it and the other two not? That's weird.
If you drew a 9 on a table right now and you walked around it, is it going to flip whenever you get to one side or the other, or is the angle to it going to change what it looks like to you, no matter where, or regardless of where, or in relative reference to where you are standing around it?
Yeah, the angle is going to change with relative.
It's going to look one thing. Hold on. So if you're standing at the top of it, it's going to look like a 9. If you're standing at the bottom of it, it's going to look like a 6. But if you're standing to the side, to either one of the other sides, so east or west, it is going to look sideways. It's not going to look like...
Yes.
So,
except, okay, now do the same experiment, except with a piece of paper that is a long way away.
Exactly.
Okay. Moving east or west by 6,000 kilometers or whatever is not going to produce a significant change in the orientation of the moon because the moon is much further than that away.
Why? Moving 6,000 kilometers north or south do anything different? A sphere's topology is symmetrical.
Because north and south, you're changing. A person in the north, can you see? Is at this angle relative to the axis of rotation, and a person in the south is at that angle relative to the pole of rotation. So they're looking out at this object. The object seems one way up when you're up here. It seems the other way up when you're down there. So moving north-south causes a change in the apparent orientation, right?
Yeah, you failed to make me see any differently on how going east-west would be any different than going north-south. Because once again, at a moment in time,
north-south, you're not doing that. You're staying like this, and the moon is a long distance away, 384,000 kilometers.
It's also that distance away for every other person.
I looked it up, having been chided by Astronomy Live. I can see him there. He's judging me.
Hold on a second, bro. If I have a basketball on my desk and I have a tennis ball on my ceiling, right, and I draw that cross I just explained on my basketball, and I put the center of the cross right underneath the tennis ball, and the tennis ball has 4 different colors on it and 4 quadrants. If I was to slide from the center to the edges, right, from the center of the basketball to the edges, I would see a different color being the closest color to me on each of the 4 quadrants of the basketball. So you saying that doesn't happen on the sphere of the Earth doesn't make any sense.
Not, oh my God!
I know you're saying it doesn't work that way in reality, but I'm saying that doesn't make any sense.
Yeah, because you're coping. We're not looking at the basketball. You're standing on the basketball, looking at another basketball.
That's the tennis ball. I know. That's the analogy I just painted. That's what I just said.
No, it isn't, because you don't have the distances correct for starting.
Yeah, exactly. That's the point.
You're breaking spherical symmetry by saying Earth has a rotation axis, as if that changes anything when you freeze time and move across the surface of it.
But regardless, you would have to put that tennis ball at what? A couple miles from you to even make it analogous to what the sun is.
Well,
it seems that what you're saying is we're measuring a real-world observation. This is what happens in real life.
But the sun isn't
And
featuring
that being on a basketball, looking at a tennis ball, predicts it, as if there's a preferred direction in space where north-south is different than east-west across the symmetry of a sphere. It doesn't make any sense.
So you understand that the moon's orbit is very close to Earth's equator, right?
Sure.
It's only off by like 5 degrees or so.
Yeah, 5 degrees is about what it's out. So it's always very close to the equator. So again, bringing up this image, if I have this angle to something that's near the equator that is far away, and I'm looking at it, and then I move down here and I'm looking at something that's far away on the equator, I'm seeing them from different. From this one, I'm looking at it from one orientation. From this one, it looks like it's upside down. But if I move east-west, if I move around, I'm not changing the orientation of that object. I'm changing its elevation in the sky. I'm changing how high it is in the sky as I move east-west. But I'm not changing the angle that I'm seeing of it.
If we took
it's not penetrating.
Yeah, if we took all the topographical features of that ball off, so it didn't have an axis, it didn't have any continents, it was just a blue solid ball, so you didn't know what north or south or east or west was, you just knew relative to you, right? And we were to put another ball above it and draw the face of the moon on it, if you were to move in any of the 4 cardinal directions relative to you on that ball, you would expect to see an orientation change of the thing above you. If you don't know what north, south, east, and west are, if it doesn't have features, would you be able to predict which direction is going to cause a flip and which direction is not?
So again, that's not true, right? If for instance, so we're talking about moving around the edge that is tangential, where you're looking tangentially towards the object, north to south, right?
I drew the cross underneath the zenith point of the moon.
Okay. All right. So again, but it's a long way away, right?
Yeah, it would be like that no matter what direction you move in. You could draw 4 equivalent right triangles in the four quadrants, the edge of the 4 quadrants bisecting the arc.
Let's consider the moon is directly overhead. Okay, let's consider the moon is at your zenith. All right, look up at the moon. Now turn around 180 degrees and look up at the moon again. Is it upside down compared to where you were at last time?
It would be 180 degrees flipped every time.
Right.
You did.
Okay. So even a person at the same orientation, right, can change the apparent orientation of the moon just by undergoing a rotation, right?
Yeah, if you take the moon and the earth out of this, bro, what I'm trying to explain to you, you can use the same distances. You can use the same distances for any 2 spherical objects. If you're on a sphere and there's another sphere above you and you paint 4 quadrants of 4 different colors, red, green, blue, and yellow on that, and then you go on and create a cross on the ground underneath you, right? These are not earth and moon. These are just 2 balls of equivalent sizes and distances. You're telling me that there would be a preferred direction in space where going along one axis would cause a flip and the other one wouldn't? That doesn't make any sense. That breaks spherical and violates spherical symmetry.
And no, it doesn't.
No,
and
it
your
doesn't.
inability. So the whole thing here is that
the people with brains can understand that does. Like, there's like a special bleeding happening right now.
Talking over me is not the way to learn. You don't understand 3-dimensional geometry, and that's okay. But if you don't understand 3-dimensional geometry, you may want to shut up and listen to somebody who does.
It's wild that you're talking over a PhD.
Along what axis is the symmetry aligned in my illustration? Since there's no north, south, east, or west, it's just 2 balls in space. Along what axis is the
You
symmetry
don't have
aligned?
a symmetry, but then again, we don't expect. So again, in the argument that you're talking about, where the moon is at zenith, right? You're considering a zenith point. You've drawn your cross underneath the ground position of the moon. In that case, there is no preferred orientation of the moon because your observer can rotate on the spot and pick whatever orientation he wants. And as he moves east or west, north or south, not a particularly large distance, he's not going to be moving. He's not going to be changing that. That is going to remain the same. He can pick, an observer there can look at whatever, there's the moon directly above me. I can rotate around. Now it's upside down. There is no preferred orientation.
Yeah,
it's only when the moon is off to an angle at the side that you start suddenly seeing, well, okay, there's my horizon. My horizon is the meaningful reference here that I'm going to judge. You might want to be quiet while I'm explaining things to you, and the fact that you aren't tells me that you aren't really listening. It is the horizon that gives you the geometric interpretation of whether or not the moon has one orientation or another. When we say that the moon appears to flip, it appears to have a different orientation relative to the horizon. This is not a meaningful concept when you're talking about a moon that is at zenith.
So the cross extends across the entire hemisphere, right?
Right.
So you would go to the edge of the cross, the 4 corners of that cross, which would be at the extreme horizon of that hemisphere underneath the zenith of the moon in the center, and all 4 of them would see 4 different quadrants of the moon closest to them.
Yes, provide
That's what I've been saying all the
time. Yes, assuming that the curvature were in any way relevant compared to the distance of the distance of the object. What you are talking about is the variation in libration with position, which has been touched upon, and Astronomy Live can produce some images of. I'm
glad we could all agree. It's now 2 a.m. I got to go, but thanks for finally agreeing with me. I think you.
Wait. I got one more question for you. You have like
that
makes sense.
30 seconds.
No, he left.
He left.
Ross
is 320,000, something like that.
You update it as they go.
So
tell it like, hey.
And so,
and that apparent angle is the angle this red line is coming into the observer at. That angle that it's coming into the observer at is the.
It was absolutely splendid.
Thank you.
Bob laying on its side, the base.
How do you explain then the water tank experiment? Because I literally show, in fact, I'll share my screen here again.
That he said, yeah, of course I use the refracted
in a balloon. He was there that morning helping me out and bought me breakfast afterwards. So thank you, Reds. I appreciate that. Appreciate all the support and help,
Very glad to see it get done.
Thank you.
So many times I've heard, "Will we
walking?"
Hard work. I should.
And I need to put that in.
Him that in person.
Muddy the waters and basically cast as much doubt on any. Alan doesn't want people to understand it.
Field, but having the skill because now that the information is out there,
doing that experiment, it's been on my bucket list because it's something
is blocking the ray from.
Thank you.
All right, and we have Piezo here. Give us some thoughts on Astronomy Live's opening.
Yeah, can you guys hear me?
Yes.
Yeah.
Cool. Yeah. So, I mean, I thought he kept it pretty concise. He did a generally good job of steel manning Alan's position. I think that initially, like in the first wave of the debate before it started getting too far into the back and forth, one of the things I disagreed with the most in terms of not like thinking it was logical was using that fish tank experiment and trying to draw it as if it was one-to-one analogous to the mountain, because he made a claim when Alan was addressing Pike's Peak, like the first observation, about the 219 versus the 217, that there was a 2 arc minute or whatever difference, which is about 8 seconds or so in real life time. That he said, yeah, of course I use the refracted position because refraction exists, and so that's where the mountain's blocked. But Alan's position is that the refracted image of the mountain doesn't block the star, and Astronomy Live's position was that the refracted image of the mountain is what blocks the star. But I don't think it's logical to say that like what's effectively a mirage is blocking the ray from the star. Rays are only blocked by solid objects.
So how do you explain then the water tank experiment? Because I literally show, in fact, I'll share my screen here again. I literally show the fact that you have here a star that is physically blocked. Nothing's changed here. The camera's in the same spot. It's physically blocked by SpongeBob here. So, are you not sharing my screen?
Yeah, give me 1 second because I left that and I need to put that in.
Cool.
There we go.
Yep, there we go. So it's this star is literally right where you see it here. This is physically what's going on there. And I demonstrated that also with the elastic band, because that is tied to the same hole as the light. I pull it taut. It goes across SpongeBob. It deflects off his base and now starts to come down at a slightly lower angle. And if you look from the camera's perspective, you can literally see that elastic band coming up and over the base and coming to the camera, even though you can still see the light. I'm starting to disturb, the concentration gradient a little bit there. I'm trying to move as carefully and as slowly as I can through the water to pull that thing taut. And you can still see that star above the base, just like you could in the side-by-side. And yet, even though it's visible, it's geometrically blocked. It is geometrically obscured by SpongeBob.
Yeah, so what I was saying is that I'll use this as an example, right? I'll use your fish tank. That SpongeBob laying on its side, the base of it being like the edge, right? You're treating that as if that's the mountain edge, right?
Right.
Is it SpongeBob's base that's blocking the star ray, or is it a mirage of SpongeBob's base, like 5 centimeters above SpongeBob's base, blocking the star ray? Of course, it's the base. A mirage of SpongeBob could not block the star ray. Only physically the base of SpongeBob would block the star ray.
But SpongeBob physically is blocking the star ray, so why can't I see the star?
Yeah, so what the point is the ray that is being traced from the star to your eye is bending, right?
Yep, just like the laser.
Yeah, so it's bending. So you're seeing a ray that's curving, and that ray is reaching your eye. If the ray didn't reach your eye, you wouldn't see the ray. So
right,
clearly, it's not blocked. The moment that it is blocked, the moment that it disappears, which is analogous to the conclusion, is the moment that that ray lowers down and strikes SpongeBob's base. So my point is that it would never get occluded unless it hit SpongeBob. It's not going to get occluded by a mirage of SpongeBob. It's only going to get occluded by SpongeBob. In similar manner, the mountain, a mirage of the mountain will never block the starlight. Only the physical rocky body of the mountain will block the starlight. That's common sense.
Okay, so going back to my intro, the very first slide I showed after the title slide, okay? Let's go back to that for a second, because this is the thing I think you're getting hung up on, is that the refracted ray is bent, yes. On the globe, we're saying that refracted ray hits the mountain, and then the mountain is also being refracted as well, and then we get to the observer. What the observer sees, to them, they perceive this to be an apparent angle that looks like the green line. It's reaching the observer at a steeper angle than the geometric line. The geometric line are these orange lines. Geometrically, the star is below the peak. Geometrically, the peak has a higher orange line than the star. But what we're perceiving it as is the angle that refracted ray comes in. and it comes in with all of the refraction that the star would have had it been unobscured. The moment it disappears, it still has the same amount of refraction as the moment before it was obscured. It disappears at the refracted apparent position. Likewise, the mountain is perceived as being higher than it actually is. It has a little bit of terrestrial refraction as well. And so you can see how the red line comes in at a steeper angle than the orange line to the top of the mountain. So yes, we perceive the mountain as being a little bit higher than it actually is as well. But it's when those two angles align, the apparent angle of the mountain and the apparent angle of the star, that's when the occlusion happens.
This destroys your prostate. This destroys your prostate.